Hey, everybody. Welcome to Total Space Network. We are bringing you a live launch of ULA's Atlas V 401 configuration. Today we are launching Landsat 9 for NASA and the U.S. Geological Survey. This should be a fun one. It's been a minute since we've seen a launch from ULA. I think they had one a few months ago. But it should be nice and fun and exciting. There's some links down in the description for some more information about us here at Total Space, other channels that we're involved with, and things like that, ways that you can support us if you would feel so inclined. Most of all, that like button is really the easiest free way you can support us. So we'd love you to click on that if you feel so inclined to grab a hold of your mouse. That subscribe button is another way you can support us at no cost. So that'd be great as well. But no pressure. Do what is right for you. We are playing around here and gonna have some fun. A nice chill launch. Drinking some coffee. I think I have a Mountain Dew sitting next to me, and I might even grab some ice cream a little bit later on. So we're glad everybody's here. Welcome. Let's see here. I can throw a comment in our chat window here. Hey, we are live. How about that? Again, we are launching Landsat 9. The Landsat program has been operating for about 50 years, just shy of 50 years already. And this will give us the capability of remapping the entire globe in 8 days. It will be joining Landsat 8 and replacing Landsat 7 in its orbit. This is a sun-synchronous orbit. The program started in 1972, and the Landsat 9 can photograph 16,384 shades of color. The Atlas V is using RD-180 engines purchased from the former Soviet Union. And we are launching from Launch Complex 3 at Vandenberg Space Force Base. This is the 39th launch of the 401 configuration of the Atlas V and the 20th launch with NASA for this vehicle. This is the 2000th launch from Vandenberg. So quite a few rockets have gone up from Vandenberg. I don't know if that counts those that didn't quite make it up as far as they wanted to, like the recent Firefly. But well, and Mr. Producer's chiming in my ear saying, or the Astro lawnmower, but the Astro lawnmower actually took off from Alaska. So not Vandenberg. It definitely did not count toward Vandenberg's total. We will be getting a feed in about 5 minutes here. So in the meantime, we have a little bit of B-roll playing in the background for you. Just some simple little clips demonstrating some of what Landsat 9 will be doing, as well as a little bit about the Atlas V and the launch site at Vandenberg. So yeah, should be fun and interesting. Again, welcome everybody. If you're watching this after the fact, go ahead and leave us a comment. Let us know what you think of the stream and let us know what other launches you would like us to try to cover. We do try to cover quite a few launches. Seems like we're streaming at least, once a week or so? Just kind of depends. Kind of just depends on what's launching and what time it's launching. I may be in the United States, but I'm on the pretty much the same time schedule as most of the rest of the team, which is pretty much most of the team is in the United Kingdom. So it's kind of difficult for us to catch some of the launches, but we do make an effort to set alarm clocks, and at least I make an effort to make adjustments to my work schedule in order to try to bring these launches to you. Um, we do all have other things that we need to do to make sure our bills are paid. So we are happy to do what we can. So it's fun and exciting. I don't know. I just enjoy doing these launches, sitting and talking with all of you. Um, Go ahead and give us a comment in the chat. I believe we've turned on subscriber only mode, so it may take a minute for some of you to respond. We're glad you're here, and we would love to hear from you. What are you looking forward to from today's flight? What are you looking forward to uh, about Landsat? What's your favorite part of the launch? Liftoff, the countdown, the goofy antics of the host. What's your favorite part? We'd love to hear from you. Let's see, I can do this. Okay. There we go. Now I can see everything on that a little better. Yeah, so we are launching Atlas 5 in the 401 configuration. 4 is the diameter of the fairing. 0 is the number of solid rocket boosters, and 1 is the number of second stage engines. So that is what the 401 stands for. And the first stage is kerosene, liquid kerosene, or sometimes referred to as RP1. And the second stage is liquid hydrogen. So should be fairly interesting. Last I read on Twitter, they have basically finished most of the fueling, propellant loading, I should say. I should be a little bit more accurate. And yeah, should be nice, fun, and interesting. Thank you everybody for joining us. We're starting to get a few people trickling in. Welcome, welcome. Glad you're here. Let us know in the comments what's your favorite thing about rocket launches in general, or maybe let's be a little more specific. What's your favorite thing about a ULA launch? Or what are you looking forward to about Landsat 9? Yeah, would Mr. Producer is saying his favorite thing about a ULA launch is Tori's tweets, which I do enjoy Tori's sense of humor. He's quite entertaining. And looks like NASA has gone live. And we have a newsroom. So nothing terribly interesting there, but there it is. Yeah, let's go ahead and flick over. There we go. Look at that. Look at that. I don't know. I wonder if we should turn off the subscriber only mode. I wonder if that's deterring people from watching. What do you guys think? Is it worth a 5-minute wait so you can leave a comment? There we go. Maybe that'll encourage some of you to chat with us. There we have a rocket coming up on screen in just a moment here. And it looks like the camera is sitting pretty close to a sprinkler, maybe. So it's a wet camera. Looks like we might need to adjust the sizing of the feed in OBS a little bit. Okay. Yeah, that might be better. Looks like a couple of them. It was at 7 earlier. We had 7 likes earlier. Appreciate all those likes, everybody. Definitely beneficial. Did we throw out a tweet about our being live? Hey, Noah, welcome. Yes, it does look like weather is favorable, doesn't it? We're just kind of chilling at the moment, waiting for things to wind up. What are you looking forward to in this launch, Noah? Here comes another view of some rockety goodness. All sorts of liquid oxygen and maybe some liquid hydrogen floating around the rocket there. Looks like they've cleaned off the camera or gone to a different camera. That's great. Yeah, they send some poor intern out there with a rag. Rag or a squeegee. Here, go run out there. Go run inside the exclusion zone and clean off that camera real quick, would you? Take the Windex with you. Have you double checked that we are pushing audio out? Check, 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 check. Yeah. Let's see. Can I? Oh, yeah. All right. I haven't seen a lot of ULA launches either. I spent a number of years where I was not paying a heck of a lot of attention uh, to the space industry until about a year ago, and then I started paying a lot more attention to it. We can maybe give you just a little bit more audio. Do you want me to do that live? Okay. Okay. Mr. Producer's giving you just a little bit more audio. Did that help, Noah? Welcome, welcome. Again, today we are watching ULA launch Landsat 9 from I can learn how to talk maybe, from Vandenberg Space Force Base. This is, where'd it go? Launch Complex 3 at Vandenberg. 39th launch of the 401 configuration of the Atlas V, 20th launch with NASA, and the 2000th launch from Vandenberg. It's the 401 configuration, as I just mentioned, which is a 4-meter fairing with 0 solid rocket boosters and 1 second stage engine. Landsat program is run by NASA and the U.S. Geological Survey and has been in operation since 1972. That's quite some time. Landsat 9 will be replacing Landsat 7 and pairing up with Landsat 8 in sun synchronous orbit. This will enable Landsat 8 and 9 to do a complete map of the globe every 8 days. Welcome, Kai. I hope I didn't just totally butcher your name. We kind of try to do things a little bit chill around here. And mostly I just like to watch listen to the rocket roar as it lifts off and watch the exhaust plume fan out. And I love to, for daytime launches, I really like to watch the vapor around the nose of the rocket as it reaches max Q. It's just really interesting how as soon as it breaks the sound barrier, the vapor just disappears. It's just really fun to watch. And then sometimes when we have onboard cameras, we get to see some separations and things, and that's always fun. Yeah, yeah, Noah, there's a ton of data that can be downloaded and looked at and viewed all over the place. I don't know the resolution. I know that it's 16,384 shades of color. Which is more colors than the producer thought existed. So it's replacing Landsat 7 that was launched in the late 90s. So I would imagine the resolution is quite a bit better than that. I think it's fairly comparable, probably slightly better than Landsat 8, but probably quite a bit better than 7. Maybe the producer can find me a resolution statistic. Yes, please. We'll see if we can get an answer for you, Kay. Kai. I'm just gonna butcher that all day long. I'm sorry, dude. Or not, dude. I'm just gonna open my mouth and put my foot in it. How about that? 15 meters is the spatial resolution. So each pixel is 15 meters. That's pretty tight resolution. 15 by 30. That's pretty tight resolution. Yes, it will be very impressive to get ice shelf data as well as river delta data and rainforest data and desert sand movement. They're going to get a complete picture of the entire globe every 8 days. Just makes me think of the old Beatles song, 8 Days a Week. I can't hum the tune or I'll get a copyright strike. So if you want to put that on your Spotify in the background, you're welcome to. Now, that's not to say that I would sing it in tune and that the algorithm would pick it up, but I'm not going to take the risk. We are at T minus, well, they're saying L minus 29 minutes. I'm pretty sure that's going to be the same as T minus. It's the traditional ULA way. It looks rather foggy out there in Vandenberg. Can barely see across the way. Hey, Astro Liz! Arm shake! Yay! Welcome! Ah. The lobby company. Well, unfortunately, that's kind of how things work in the space industry, is especially here in the United States. Is you kind of have to lobby to some degree or another, and every company does it. Some are a little bit more vocal about it. Some are a little bit more what's the words I'm looking for? Enormously complex and high risk, shall we say? Yeah. Some like to use extremely large PDFs that crash systems. Hmm. You're ready to shake. I'm glad you're ready to shake, and I'm glad you're awake. So happy you're here, Liz. I was threatening earlier that I might go and get some ice cream out of the freezer. We'll have to see. We'll have to see how it goes. But I made sure that I have some ice cream in the freezer for today's launch, just in case you showed up. So we're glad you're here. Ah, pasta. Nice. Star and moon shaped pasta. That sounds very filling. We had at work, they provide breakfast, and today it was probably the worst grilled cheese, ham and grilled cheese sandwich I have ever had in my life. I think I had better ones in school lunch growing up. So that tells you where the bar was today. Sometimes the food's pretty good at the studio, but they didn't quite accomplish that today. We are just under 25 minutes to launch or liftoff, whatever you want to call it. Assuming there are no holds. I am looking forward to, I'm going to pull some volume up. Maybe it'll give me some things to talk about. I think NASA just keeps replaying the same video too. NASA has a guy pressing B-roll buttons. Yeah, NASA has definitely caught on to the theme that they want for this launch, and it's very 90s themed. They got the fuzzy microphones and haircuts to go with it. Not this wonderful lady here, but the gentleman host was just talking before that. Got a very 90s haircut. No Miko today, Liz. I believe he is still at work. Though he or maybe one of the other hosts might drop in a little bit, but I don't know. I don't think they plan on joining. I get to fly solo in front of the camera and have Mr. Producer in the on the other side of the camera and on the other side of the pond. He's melting away in a sauna. That's very possible. Maybe let's bring up some stream audio here. And yes.
Crisis right
And
now. We
I
see that every
am
day.
going
Drought,
to
wildfires, hurricanes. Hurricane
go
Ida
off
that
screen for
devastated parts
just
of the
a few
South and
moments.
went all the way up to New England. Images like the ones that Landsat 9 will bring back to us will help us tremendously to guide us in how we are approaching climate change, working to make sure that we can make the best decisions possible so that folks have water into the future, that we can grow our food into the future. These are all things that will affect the daily lives of every single American, and quite frankly, these are pictures from around the world, not just the United States. So it's going to help folks all over the world to make those decisions, and it's unmistakable, incredible, hard data that we can use every day.
Absolutely. Thank you so much, Secretary Holland, for being on the show. Back to you, Daryl.
We are now L-20 minutes and counting until launch, and we've been monitoring the launch teams with our headsets. We're plugged in, and Mick, you just got some good news.
Yeah, we did. We got to hear from the launch team that everything is go. They're back on schedule. Things are working well, and we are green for our 11-12 launch opportunity this morning. So that's exciting that we're getting ready to launch Landsat 9.
That's great news. We've got a little moisture on the camera, as you can see there. There's a little mist in the air. There's some fog, and there's a marine layer, but none of it is expected to stop this opportunity today. Mick, want to talk about the launch time at 11:12 a.m. Pacific time. That actually moved 1 minute. What was the reason for that?
Yeah, Daryl, we moved the 1 minute to 11:12 this morning in order to accommodate a COLA, or what we call a collision on launch assessment. For the C-Train, the C-Train is made up of two satellites, Calypso and CloudSat, that LSP launched back in 2006, and we want to make sure that when we launch Landsat 9 this morning, we get it in that near-polar sun-synchronous orbit, but we don't want to hit our fellow satellites that are Earth-observing. So to avoid that, we made sure that Landsat 9 needed where to go. We moved the launch by 1 minute in order to avoid the CloudSat satellite.
Got to have room in space to get to space, and so we are looking good from that aspect as well. As we look at a shot here from the pad, you can see the steam that's coming off the rocket. Those are just vent valves, right, that are venting off excess liquid oxygen.
Yes, Daryl. Actually, as the team is finished up, we're in what we call topping mode. And as the liquid oxygen, liquid hydrogen boils off, that's what you see coming off there. And as we get ready to go into T-4 and counting, you will see those vent valves close, and that will stop and bring us to flight pressures.
Now, as you look at that rocket, there's actually a special dedication on it. You can't see it, but we're going to show it to you in a second. There's a special dedication there, and the reason is it's because of this man, Thomas Heater II. Heater began his 45-year career in the launch business at General Dynamics and relocated here to Vandenberg as a flight test engineer in the mid-'60s. He rose to director of Vandenberg launch operations, and during that time supported 200 Atlas, Titan, and Athena launches. Heater II passed away several years ago, and so ULA put this special dedication to him on the side of the Atlas V rocket, and you can see it there in memory of our colleague and friend, Tom Heater II. His family and friends gathered around the rocket as well and took a photo. And Nick, you had the privilege of working under Heater II, and may I just point out,
I think Inspiration 4 was the funnest to cover.
Thomas Heater II's son, the third.
Both
Yes,
the
Daryl,
launch
Mr.
and
Heater
the
was a
splashdown
remarkable
were quite a
leader,
bit of fun to
humble
cover.
person, and you know what? I did. I had the privilege of working with him on many Atlas missions here at Vandenberg Space Force Base before I started with NASA. Mr. Heater was the director of launch operations at Space Launch Complex 3, but what I remember the most is he would always keep an eye on things going on at the pad, but he always took care of his people and looked out for things.
You don't want an invite to the
launch services program. We get to work with his son,
the hot tub for
today's
Christmas.
Launch director, who we will hear
Is that
from
what you're
later,
saying
and
there,
he's a remarkable
Mr.
person
Producer?
also.
Well,
great dedication to the Heater family.
Indeed, and we'll hear him report out as the last in the L-7 poll. We'll get to that in a bit. But first, I want to talk about LSP and their ability to bring together the rocket and the spacecraft.
Since the dawn of humanity, we have looked to the stars and dreamed of bridging the gap between the Earth and the cosmos. In the 20th century,
look at all those
NASA
patches.
turned that dream into a reality.
Yeah,
by
that's a
launching
lot of
humanity
patches.
into a bold
Somebody had to
era
do a
of
lot of
scientific
needlework to get all
discovery.
those patches sewn on there.
As pioneers of space travel, our best and brightest designed and built everything from the ground up, from launch pads to rockets, all of which were government owned and operated. As NASA's science and robotics evolved, we encouraged a competitive launch market to develop, ushering in a new way to explore and discover through commercial spaceflight. Spacecraft customers from around the world, all with the same desire, reached out to find an expert at NASA for support. Thus, NASA's Launch Services Program was born. Our mission is to centralize NASA's launch services and address state-of-the-art customer needs when placing their spacecraft in orbit around the Earth, the Sun, or destinations deeper into the solar system. The LSP family is made up of a diverse tapestry of government and contractor engineers, analysts, operation experts, and business advisors.
Absolutely. We're all going to have to be extra good now.
Spacecraft off the ground on
I know. I've got probably a couple things to make up for where I didn't make the best decisions this year. So I better whip it into shape. We're on the home stretch for Christmas now. Better make my bed every morning and brush my teeth, or I probably won't even have a Christmas tree.
The Launch Services Program is the common thread that bridges the spacecraft organization to the rocket designer, and the spacecraft to the rocket. We provide long-term technical leadership and expertise from pre-mission planning to system verification and validation, all the way through launch. Whatever the vision or requirements, our team will be there, guiding our customers every step of the way on their journey through space. We are the common thread that connects the science world to the physical world by putting the necessary instruments in place. The thread that weaves NASA's industry and support.
You know, you pick a really good one there, Noah. USS F-44. Holy cow, I can talk.
And culture.
Is definitely on the list of ones that I'm looking forward to. We got Lucy launching in about 2 weeks. We've got Super Heavy probably, most likely, in a little over a month. We have SLS. Yeah, the Super Heavy Elon time. I think the main thing that's going to be holding that up for now, though, is the public input on the environmental assessment. And there's a link to the environmental assessment in the description here. If you haven't had a chance to read that, we put that in the description. And I think somewhere in that assessment there is a link for public comment. So feel free to let the FAA know what your thoughts are on that environmental assessment. Yes, I do hope SLS launches this year. I think it will. It seems to be tracking, it's going to be tight, but it seems to be tracking like it will be launching this year. It looks like Starliner has been pushed to next year. Pretty sure on that one. We have Crew 3 launching on SpaceX Dragon, launching later this year. That's crewed launches are always fun. We have James Webb launching later this year. Ariane launches are always, that's a big rocket, you know. But I mean, it could be overshadowed by a couple of bigger ones, but a few bigger ones actually. But the Ariane 5 is quite a big rocket. So it really belongs to once you take those other big ones aside.
Absolutely. And Landsat obviously looks down on Earth, surveying the entire planet. Does
hey,
we learn from Landsat
Marco.
help us turn
how you doing, buddy?
Good
to see you.
Into the solar system?
Absolutely. You know, the work that we're doing in all of
you got an award on Friday at school.
Science, we have
that is so exciting.
To the Trojans, a planetary mission, the James Webb Space Telescope launching later this year, and we use.
What is the Superstar Award? Is that does that mean you did a nice superstar dance to get the award?
Looking at our planet, so yes, we learn from there to here, but very much we learn from the Earth science instruments to look at how we explore other planets.
Sure. I want to also ask you about this huge treasure trove of data available for researchers. It's available to the public. First, we have a quick video to explain that.
Landsat archives its 9 millionth scene. Each scene is a satellite image from space,
We
about
are
115 miles wide.
getting close to what, about
Researchers and, well, just about
10,
anyone can
10-ish
download
minutes
scenes
to
from the Landsat
the
archive
launch? We
managed
probably
by
won't be
USGS.
watching too much more of this
Landsat holds the title for the longest
super
continuous
exciting
space-based record
B-roll.
of Earth
Oh,
in existence.
just under 11 minutes. That was a pretty good
That's
guess
50
for not
years of
really
scenes
paying
like
attention.
these, helping scientists and researchers
So if
understand
anyone
how our
has
planet is
questions
changing over time.
or comments, we'd love to see it
So we
in
just saw a
chat
video
there.
about Landsat having archived
Do our best
9
to answer
million
it if we
images
don't
and counting.
already
We're adding
know.
700
There
every
are
day
some
to that.
CubeSats also
Until
going
the
up.
earlier
There's a
2000s,
little
this
bit of a
data was
ride
not
share
free.
on this,
People had to pay
but there was
per
not
scene.
a ton of
Now that's completely
information
free. It's available to anyone who
readily
wants it. Why
available
is that so
on
significant?
Well, it's
the
absolutely
CubeSats
essential
that are
to
going up.
unleash the
Let
power
me
of the
see.
data that
I
we
found
have. Of
one
course, our
piece of
partnership with USGS remains strong.
information.
They are our, if you want, translators of really the images to the application spaces in our world, whether it's agriculture, fisheries, and beyond. But by making the imagery public, what happens is that companies, non-for-profit or for-profit companies, can take those data and put their own data on top of it and actually add to the value of the Landsat data in ways that otherwise would not occur. So it's a huge stimulant on entrepreneurial thinking of the type that the US is known for.
And beyond
There's a
Landsat,
couple of
we're looking forward to launch in
educational
10 minutes or so. But real
nano
quickly,
satellites.
what else are you looking forward to this year for the Science Mission Directorate?
Wow, it's an amazing year. Frankly, there's
There's
hardly ever
a
been
cute
one
satellite,
like
Colorado
just,
Ultraviolet
2-3 weeks
Transit
from now,
Experiment,
mid-October, we're going to launch Lucy.
coming out of Boulder. Been through Boulder. It was a nice little town. Boulder, Colorado really reminds me of where I live here in Utah. It's a small university town. It felt just like home.
With a nearest object.
All right, Dr. Thomas Zerbuchen, thank you so much for joining us.
There's
Enjoy the
also
launch. And with that, let's send it
Alana
over to
34,
Daryl and Nick to take us through
which is
these final
a
minutes
Cupid
before liftoff.
satellite.
Guys.
All right,
Cusp
thank you, Marie,
plasma
and welcome
imaging
back into the
detector,
Mission Directors Center. We've been listening to the
from
launch
Boston
team and just got
University.
some great news from NASA launch manager Tim Dunn.
And that will
declared
be
that Landsat 9
measuring
is
interaction
now on
between
internal power.
solar
That means
wind
things are looking really good.
Yeah, Tim
and
Dunn completed his
the
poll
upper
with the
atmosphere.
Team, notified them that weather looks good, the range is good,
It's kind of
spacecraft
worded
is on
funny
internal
where I'm
power, like
reading
you
it.
said, Daryl, and those are all good indications that we are go for launch at 11:12 this morning. So excited to hear about that. The next up, we will hear from United Launch Alliance launch conductor Scott Barney. He will perform at L-7, the ULA Teams poll, where we will hear.
I can't wait to see this launch.
Earlier, Launch Director Tom Heater will give that final.
Hear that
proceed to
engine
launch.
roar.
And of course, a dedication going up on the rocket with his name on it. His son, as you mentioned, the launch director. We'll be listening for
That's
that
a
poll,
great
which is
idea,
coming at
Liz.
L-7 minutes. If you look across the bottom of the screen,
Do
you
something
can see
for
where
Tori's
weather briefing
birthday.
coming up is polling, and we'll
That
hit
would be
that
quite fun.
at L-7 as we count down. 60 more seconds until that moment. As we look out at
I
the
wonder.
rocket, we see that they've had a little bit of
I
clearing.
wonder
That doesn't affect
what
the chance for launch.
we could
But Nick,
do
it's nice to see
for
that
Tori's
there's a little more
birthday
visibility,
as a space
4 miles
community.
visibility, which is exactly the distance between this rocket
Maybe
and our
we could
host
start
base, where
a
Marie is, and the launch
happy
viewing
birthday
area.
Yeah, I
thread
feel a
where
lot better
everybody
seeing some of that
replies
fog
to the
clear off, and
thread
Marie will be able to actually
on
see
Twitter
something from
saying
where she's
happy
located.
birthday
With
Tori,
all the guests she has up
and
there,
just
that's
make a
exciting.
big
Like you
thread
said, the weather is
for
really
Tori
cooperating with
Bruno's
us this morning,
birthday
and as this fog here in Vandenberg moves out,
on
weather
Twitter.
still remains go, and the United Space Force has assured us that we
That
have
might
a
be
green
kind of
all
fun.
the way through launch.
And once they go
People
green,
could
and once
include
this thing launches, it will be the
pictures of
2000th
their
launch
their
from Vandenberg
favorite
Space
ULA
Force Base, as well as the
rocket
300th
or launch or
Atlas.
something
Let's
along those
listen in now
lines.
as they conduct that poll.
L-7 minutes.
We're
Status check.
going
Proceed
through
with terminal
final
count.
go no go
Propulsion.
call outs
Go.
right now.
Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go.
Hearing a
Step
lot of goes, that's a good sign.
Pneumatics. Go. LO2. Go.
Seeing
LH2.
some
Go.
good
Gas. Go. Electrical systems airborne.
Some good
Go.
little
Ground.
poofy clouds
Go.
coming off
Facility.
the rocket
Go.
there.
RFFTS. Go.
Looks
Flight
a little
control.
bit frosty.
ECQ.
Go.
Operation support. Go. Com. Go. Umbilicals. Go. ECS. Go. Red line monitor. Go. Quality. Go. Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go. Range coordinator. Clear to proceed. Launch director. You have permission to launch. ALC. Verified T0 is set for 1812 Zulu. Verified.
1812 Zulu, that's UTC time, and we are go. And I got to tell you, it was nice to hear Tom Heater III give that go right there at the end.
Absolutely. I got goosebumps here, Daryl. Every time we get to this point in a launch, it is great to hear the team give their goes. And this is special for me, too, to dedicate this to Mr. Tom Heater II and hear Tom Heater give that proceed to launch. That is so... I can't even explain how I'm feeling right now. I'm so excited for Landsat 9 this morning. Looking forward to this launch.
His family and friends also here present to watch this with all of us. We are now counting down.
I
to
think
the
I just heard the
T-4
producer
hold,
scream
where we're
like
gonna get
a
those clocks synced up with the
like a
T-clock
little
and the
young
L
lady.
clock. This has kind of been a windy road to get to this point, though, Mick. This
I
launch
think you
originally
saw a big
scheduled,
spider.
for
I went
September,
walking out my door
16th.
this morning,
It moved to the 23rd.
and
There
I
were some
saw
issues with liquid
the
nitrogen getting
hugest
to the
spider
pad
I have
because of a
seen at my house
COVID-19 induced
in quite some
issue
time.
with liquid oxygen back in Florida.
I think it was big enough to knock me over. It was
also had a little issue with
huge.
the spacecraft getting it up because of the winds, but Launch Services program stuck with it.
I think I might have squealed a little bit myself when I saw it this morning.
I'm very proud of the team. NASA's Launch Services program, our commercial partner, United Launch Alliance, the United States Space Force. They worked hard
coming up
to
on
get through
4.5
this.
minutes to
It has been a windy road
launch.
to get here, but you know the team's dedicated. This is just part of the rocket business, and these guys have maintained their processes, followed through their procedures, and worked diligently to get us here today, Daryl. So I can't say enough about the teams that have continued to bring us here for Landsat's launch this morning.
As we approach the T-minus 4 minutes, what do we expect to hear?
So we're going to hear them pick up the count.
The time will be T-minus 4 minutes and counting. 3, 2, 1, mark.
So we just heard now the L clock and the T clock will sync up. We are now entering terminal count.
I
At
think you'll
T-minus
find
3,
it
we will hear the
very,
team secure
very fun
topping
and interesting.
verify that everything's at flight levels.
You can
Around 2
probably
minutes and 50 seconds,
put it
we will
on
hear
your
that the flight
backpack,
termination
hook
system
to
will go to
one of
internal
your
power,
zippers
making sure
maybe
that
or
all the
something.
safety protocols are on the rocket as we launch this morning. And around 2 minutes, we'll
Might
hear
be
that the
kind of
Atlas
fun.
and Centaur vehicle go internal on battery power, which means is a clear signal that we will be launching on time this morning. And then at 1 minute, we will hear the United States Space Force give us a range go or green thumbs
it's hard
up,
to see
and we will then proceed into
the
our
vapors
T0
coming
mark
off the
for
rocket with
Landsat
all
9
that
this
fog
morning.
in the
As
background.
you can see there, the rocket
What do you
against,
guys think of all that fog?
dreary backdrop with a marine layer and a little bit
There's
of
a
fog.
top-down
It's
view.
93% humidity here along the central
It's a
coast of
frosty
California.
rocket.
It's about little less than 60 degrees in the temperature that's outside. None of that is a factor. Over the past few days, we've also seen some smoke from a nearby wildfire at Sequoia National Forest. There you're looking right down the side of the booster, the Atlas V booster, and seeing that condensation coming off that super chilled skin of the rocket.
Yeah, I love that shot, that rocket cam shot. That'll be a great shot as we lift off this morning. And as you said, seeing that super chilled
coming
tank
up
as it
on
filled with liquid oxygen,
2.5
liquid
minutes
hydrogen
to lift
on
off.
the Centaur tanks this morning.
Hey,
we're just excited
Spartanac.
about this. And we just heard from the team that
Welcome,
they're
buddy.
going to flight levels
Good to
on
see
the
you.
on the tanks. And so that's a good sign that we are getting ready to close those vent
Just
valves
in time.
and move into what we call step 3 for flight pressures.
Once that rocket lights, that orange fire will certainly change the light and change the mood of many of the folks who are watching this.
It's your call. You can go full screen or leave the overlay up. I think both will be fine.
You can see on the progress bar, we are go for launch. Our next point is liftoff.
Hey, there's
We just
Miko.
heard the call, Daryl, for vehicle internal. That's a good sign. We're going to hear
Just
the last
in time.
call
Man,
here to
everybody's
verify
flooding in
everything
right
goes.
just in time.
Securing center
We got
holotape.
Spartanak and Miko both showing up just in time for
There's
liftoff.
where they're securing and shutting off the vent valves and securing the
140.
vehicle.
Launch enabled. 137.
FTS armed.
Flight
And
termination
a
system
little
is
bit
armed.
over
We are
30 seconds
getting
here.
closer and closer
I'm
to that
going
T0 mark,
to
Daryl.
And there's a big moment.
mute up my
at
microphone,
T-minus
and
45
we
seconds.
can
What do we
listen
hear
to
We're going
the
to hear the
engine
launch
roar
conductor, Scott
as it
Barney,
lifts off,
verify from the
and then
last
I
minute
will come
that
back
everybody's
in
ready to go, and we
once
get a
the
green to
engine
go for
quiets
launch.
down a
It's
little
been
bit,
a lot of work
and
to get to this point.
unfortunately,
of
we're not going to
preparation.
probably see a heck of a lot of
There we just heard vent
engine
valves locked,
plume
and as you saw,
or
Daryl, you pointed out earlier that
max Q
steaming off
vapor
the vehicle has
action,
now
but
stopped. Vent valves are up.
Rock,
that's
report
okay.
range status.
It's okay
Range
as long as we
green.
get to hear a little bit of
That's a
engine
great
roar.
sign to hear range is
Let's
green, Daryl, that we
let's
are
light
good
the
to go.
candle and an arm shake. Liz says.
Coming up on
Everybody
that
do an
poll
arm
from
shake
launch
for Liz.
conductor Scott Barney.
40.
Okay, I'm going to mute up my
Stabilize
microphone now, and we'll talk to everybody in a little bit here.
Three, two, one. Engine ignition. And liftoff. Liftoff of an Atlas V rocket and Landsat 9, continuing the legacy of an irreplaceable 50-year record on our ever-changing planet.
Control system response looks good. RD-180 engine operating parameters continue to look good. Vehicle has begun the pitch over maneuver. Body rates look good.
That pitch over maneuver heading it to the south towards Southern California and down to Mexico.
Now passing 40 seconds into flight. Engine operating parameters continue to look good. Pump speeds and injector pressures all within expected ranges.
There's a shot from our tracker cam above the marine layer.
Now 55 seconds into flight.
Sure
Vehicle is now completing the pitch over maneuver. Body rate responses continue to look good. 3 minutes remaining in the boost phase of flight.
Zero distance
Pump speeds and
downrange,
injector pressures on the
16
RD-180 continue to
miles
look
up,
good.
17, 18. I don't know if they're going quite that fast.
Body rates continuing to look good. And at 1 minute 20 seconds into flight, Atlas is now supersonic. Vehicle passing Mach 1.
A critical moment for the rocket.
And vehicle is now passing max Q, maximum dynamic pressure. RD-180 performance continues to look good throughout boost phase. Engine's now throttling down slightly as expected. Engine response looks good.
That throttle down reduces the stress on the 19-story tall vehicle.
At 1 minute 50
the
seconds into flight, vehicle is now 10.7, correction, 13 miles in altitude, 7.9 miles downrange distance, traveling
There's
at
a little bit of
1,500 miles per hour.
Engine exhaust action going on.
Now just under 2 minutes remaining in the boost phase of flight. At 2 minutes 18 seconds, the Atlas V vehicle now weighs just 1/2 of its liftoff weight.
That's just beautiful.
And vehicle's gone to
Just
closed loop
beautiful.
guidance. Body rates indicating a slight adjustment can be expected for this phase of flight.
There's a beautiful shot right there, looking back towards the planet. And see the plume from the RD-180.
That sure is an interesting
And the reaction
view.
control system on the Centaur is now pressurizing to flight levels. System pressure response looks good.
So the reaction
2
control
minutes,
system
50
on
seconds in
Centaur,
flight.
they're prepping it.
RD-180 engine operating parameters continue to look good throughout
That's
boost phase.
just that-
Body rates remain stable.
That engine plume flare is
60
just
seconds, the booster engines will cut
just
off.
gorgeous. I like that
Approximately
black and
1
white
minute
shot.
remaining now until booster engine cutoff.
What do you guys think of that camera work there? We're doing a pretty good job following the rocket.
3 minutes, 15 seconds into flight. Atlas is 48 miles in altitude, 70 miles downrange distance, traveling at 5,600 miles per hour.
Great shot as it goes out over
I think
the Southern
ULA's
Pacific.
gotten a new cameraman.
Pump speeds and injector pressures on RD-180 continue to look good throughout boost phase. And the Atlas V is now throttling to maintain a constant 5G acceleration limit. Engine response looks good.
Speed currently 7,700 miles per hour.
Begun boost phase chill down.
Coming up on booster separation.
Now throttling to maintain a constant 4.6 G
cut off and then
acceleration
separation.
limit in preparation for BECO.
This is where the booster engine cuts off and then separates.
And we have BECO booster engine cutoff standing by for stage set. And we have good indication of Atlas Centaur separation. We have pre-start on the RL-10, standing by for ignition.
And there you see the
booster
separation.
falling away.
We have ignition and full thrust on the RL-10. Chamber pressure
There
looks
goes
good.
the fairing.
Look good.
Coming
Beautiful
up
shot of the
just in
booster
a
falling
second for
away
you
as you're looking
guys.
down.
Good indication of payload fairing jettison.
And you should see the
This
payload
first burn
fairing.
today
Sometimes they come around the side.
12 minutes, 11 seconds.
There you see one.
RL-10 performance continues to look good in the early part of this first burn. Now passing 4 minutes,
Haven't
47
seen,
seconds into flight.
Second
So
stage
we're in a
start
good point,
yet.
Nick. Flight is looking good. We're going to monitor the situation here. But what
Plus,
a
we
beautiful
can't-
launch. What a beautiful flight so far.
5 minutes.
But there's still a lot of work to do.
Yeah, absolutely. A lot of work to go on, but beautiful shot there of the RL-10 engine in space, sending Landsat 9 onto its orbit. A great launch this morning. So excited for this.
We're getting some of that orbital sunrise on the engine bell there, and that's just a neat look as you look back at our planet. All right, Marie, we'll keep track of things in here, but for the meantime, we'll send it back out to you on the hill.
All right, thanks, guys. We did get lucky enough for that marine layer to clear so we could see liftoff from here at the gravel pit.
I'm a little nervous. What do you guys think in chat there?
About today's launch. Take a listen.
Did we
NASA
see a
Administrator
failed
Bill Nelson,
start?
thank you so much for joining us. You have described climate change as an all-hands-on-deck global challenge that requires action now. Tell us, how does the Landsat program help leaders take action now to address climate change?
I'm a little nervous.
We best get on the business of doing it right now. And what Landsat does, it is the longest continuous global satellite record of the Earth's surface. And these satellites have documented Earth's changing landscape.
Yeah. Noah, I think you're
scientists.
I think you're onto something. I think we were supposed to see a
and all of that is needed to sustain
Centaur
human
start
life.
there, and we
Such
didn't
things
see
as
it.
food and water and forest. And of course,
that's,
Landsat's long-term record of our home planet allows us
hopefully they're able to get it
track
started
the
in time.
changes and the impacts of climate change.
And President Biden's fiscal year 2022 budget requests
It is kind of hard to see
for NASA. That's a 6%
hydrolox
increase from
burn.
last year, and also the
It
strongest
doesn't have
budget
the
NASA has
the
ever
cloudiness
had
and
for science.
the
How
darker
do you
colored
quantify the
clouds
value of
that
NASA's
we would see
science
in
missions?
It is a
like we did in the
very
earlier
strong
RP1
budget
burn.
request.
Kerosene, the kerosene
The value
definitely
is immense.
definitely has a
And
black
when you're
cloud. Oh,
talking
there's
about
Miko
data
chiming
like
in.
this, it's hard
We might
data
not have
that
been able to
arms
see it
decision makers with the tools they need
at
to
all.
make tough decisions
So
about our future.
yeah. All right.
It's exploration
like
on
I
other
have
planets, helping
rent
to
due
answer
on
the
my
age-old
coffee again.
questions. How did we get there?
I will be
Are
right
we
back.
alone? It's the inspiration of the next generation. That is what this science budget is all about.
And besides Landsat, in what other ways is NASA making it a priority to understand and respond to climate change?
Well, we are doubling our efforts to lead when it comes to climate science. Earlier this summer, we announced a new Earth Systems Observatory. It's going to be 5 great observatories that will look at the land, the oceans, the ice, and the atmosphere, and combine a 3D composite of what is happening very precisely to our atmosphere. That, combined with all of our other existing assets, such as the Landsats, it's going to develop the ability for us to really measure what is happening. And also, we're continuing to develop resources for sustainable aviation. That is less pollution in the air from aircraft, and it will keep industry in U.S. competitive and drive fuel efficiency that helps the environment.
So we did see quite a bit of shaking of the bell nozzle
Thanks
there.
a lot. Have a great day.
Earlier.
All right, there is a live view on your screen now of Landsat on its way into orbit.
Hey,
Turning now
Justini.
to one of the many practical applications of Landsat, the U.S. Department of Agriculture uses it to track annual yield of every crop grown in the United States. Disaster managers can see impacts from floods and other natural disasters. Resource managers can use the data to direct crop rotation and monitor water use. Take a look.
America has always been a fertile land. Grasslands and forests and farms.
Liz
from
has
sea
started
to
something
shining
with
sea.
Total Space Network.
The
We
U.S.
do the arm
Department of
shaky now.
Agriculture tracks how many acres and the annual yield
That's great,
for
Miko.
every crop produced. From the big ones like corn, wheat, soy, to regional crops like cotton, rice, citrus. They track every year using data from
High-speed
Landsat
launch.
satellites and others.
I like watching
combined
launches
with
in
data
high
from
speed.
surveys on the ground. Landsat satellites see detail at the human scale, about the size of a baseball diamond, and can image individual farm fields. The program started in 1997 with North Dakota as an experiment. Other states became interested, and the program grew. In 2008, Landsat data became free to use, and the USDA could afford to map 48 states.
Yeah, I didn't know that either.
During the growing season,
I don't think
the
I
data
have
helps
ever watched
estimate crop
a
yields,
Centaur launch,
which helps
a
farmers
Vulcan
and traders
launch
set
before,
prices
so
for the harvest.
I was not
Thanks
aware
to
of that.
Landsat's detailed view, the USDA tabulates stats crop by crop, county by county, and state by state. At the end of each year, the data set is released to the public, and it is a beautiful sight. The patchwork of corn in yellow and soybeans in green in the Midwest. The diversity of crops in California's Central Valley. The clusters of citrus in Florida and California and Texas. We can see changes in farming through the years. The easiest to see is crop rotation in the Midwest, cycling between corn and soybeans. In northern North Dakota, there is a shift from barley and wheat to soybeans and canola. And we see an increase in cotton fields, shown in red, in Texas and Oklahoma. Thanks to the free and open access to Landsat data, the U.S. Department of Agriculture is providing our farmers with accurate data and helping maintain our nation's food supply.
All right, we want to bring in a special guest now from Northrop Grumman, the company that actually built the Landsat 9 satellite. Frank DeMoro, you are the Vice President of Tactical Space Systems for Northrop Grumman.
I wonder if he's related to
And I
Gorbachev.
understand this is your first launch out here at Vandenberg. How was it?
It was really special to see that rocket lift off. There's
Yeah, well, I
nothing
tell
like it.
you,
That's
we
probably
got a
not
little
very
lucky.
funny.
It's
It's
also
kind of
my
mean.
first
I should
one,
probably
so
shouldn't
we shared
say
that
that.
together. But the last couple of days, it's been the marine layer has been so thick. It's been very hit or miss. Our view from here to the launch pad 4 miles away. So we lucked out. I'm glad you got to see it lift
Yeah,
off.
it was a special time. Special time.
So this is Landsat 9 is the 4th satellite that Northrop Grumman has built for NASA. Tell us about the process. What goes into building a Landsat
Frank
satellite
DeMoro.
or integrating it with the instruments?
Yeah, well, of course, the
Northrop
satellite
Grumman.
that we build, the platform part of it, is really there to carry these special instruments to do the work that Landsat 9 is going to do. And so we have a dedicated team of engineers in Gilbert, Arizona, where we actually designed and built the satellite, working closely with our NASA customer to make sure that the structures and the power and all the data transfer systems are all in place to be able to accommodate the instruments. And then once we put that all together and put the instruments on the spacecraft, it goes through a rigorous test process. So that when we deliver it here and it gets launched like you saw today, it's ready to go.
There are so many things, as you know, that have to go right for a rocket launch to happen. And certainly the workers that you described in Gilbert, Arizona are a big part of that. You know, all of the meticulous work I'm
Welcome.
sure
We
they had
have
to do to get to
just
this
watched
point. Can you
the
talk a little bit about that team, you know, what
launch
it's been
of
like working through
Landsat
the COVID
9
pandemic and any impact that's had at all?
by
it's a
ULA
really special
aboard
team, and they're so
the
dedicated to this
Atlas
mission.
5
The fact that this is our
rocket
fourth Landsat
with
mission,
a
partnering with
401
NASA all these years in this
configuration,
type of mission
4
is really
being a
special.
4-meter
And the team
fairing,
understands that. And as they've
0
worked through the
being
past year and a half,
0
they've just continued
solid
to
rocket
work through the
boosters,
COVID
and 1 being a
period,
single
being
engine
dedicated
on the
to this
second
mission,
stage.
knowing what it really means to NASA, what it really means to the nation to get this data down to the ground. So
I don't
they've
know how I
persevered,
feel about the
they've
Bill
worked really
Nelson
hard,
era
and
just
I'm
yet.
really so proud of them. Mainly, that's the main thing I'm most excited for today.
He's
is
got
what the
some.
team
He's
gets
got
to
some
do.
mighty shoes to fill.
You and the Northrop Grumman team.
Well, thank you very much.
Replacing
Appreciate it.
Jim.
You're welcome. Thanks for being
And
here.
I think
All
a
right,
lot of us in the
we
space
are now
community
at launch
are
14 minutes 37 seconds
really
and counting.
missing
We
Jim,
expect Landsat 9
even
to
though
reach
we
orbit,
don't.
its
We haven't
intended
seen a
orbit
lot
in
of
just a few minutes, and
a
here's
lot of
some
what
things
Bill
to know
can
about
or
that.
can't, will or
It will
won't
circle
do
the
for
Earth
us
at
in
an altitude of
the space
438
fan
miles. It will travel at
sector. So
16,760 miles per
the
hour,
jury's still
or
out on Bill for me.
4.6 miles per second. Each orbit around the Earth will take 99 minutes, so Landsat 9 will complete 14 orbits per day. Landsat 9 will take more than 700 pictures of Earth every day. All right, and as I mentioned, we are approaching that orbit milestone, so let's get over to Daryl and Mick to take us
lower
through
stage
the
has
next few minutes. Guys?
That's right, Marie. We are just
RP1
seconds
or
away from
kerosene,
main engine cutoff. Centaur has been burned
that
now
has
for several minutes. It's really close. When this happens,
more visible exhaust.
Going to be in an orbit.
There's more
it's a little
carbon.
Bit just heard we're just about a minute out.
Yeah. So what's happening is we have
being
this first burn
let out in the
we're
burning
trying to get
process.
a slightly lofted orbit this morning
Whereas hydrogen, liquid hydrogen does not have
main engine cutoff will occur, and then
carbon.
we'll coast
so
for several minutes.
It's a
as
much
it get Landsat 9 into the
clearer
orbit it needs to
burn.
be, and then we will get spacecraft separation.
I didn't realize the flame itself would be invisible as well, but
hard to believe.
Yeah,
we're
so I
just a
learned
few
something
seconds
as
away
well.
from main engine cutoff, but hard to believe this spacecraft and this rocket have gone almost completely around the planet. Currently coming up.
Yeah,
through,
I mean they're showing
Eastern
flame
Africa,
on
over Turkey.
the animation
We're
here.
just seconds
So
away. Let's listen in to the call for main engine cutoff.
yes, I agree, Liz.
And
Jim was
Miko,
very
cut
good about getting everyone excited about
Body rates
space.
look good. Vehicles now
And
recovering from
I hope we can see
shutdown transients.
some more of that from
And there
from
you go,
Bill.
Daryl. We heard from United Launch Alliance commentator Patrick Moore, who's done a fantastic job since liftoff of filling
I
us
hope
in on
we
all
get
the
to see some of
activities that
that.
have been going on, and we just got confirmation of main engine cutoff. So Landsat 9 and the Centaur will coast for a little bit, and then we're about an hour and 3 minutes from Landsat 9 separation.
Yeah, it'll coast for a lot of bit, right? Because as you can see in the bottom of the screen, we have removed our progress bar.
We
with
are
the milestones,
probably going to
and
be
now have
kind
a
of
new
in
progress
chill mode
bar,
as
which
we
will show you the
have
time to spacecraft
a
separation,
little over an
which you can
hour
currently
until
see
payload
is set at
separation.
an hour and 3 minutes. We'll be monitoring everything here, but once again, we'll send it
I'm
back out to the
assuming
hill
that
with
Mr.
Marie.
Producer can stick around that long.
All right, thanks, guys. Joining me now is Landsat 9 project scientist Jeff Masick. Jeff, thanks for being here. How was the launch?
It's incredibly exciting
Yeah.
and successful. So, you know, everybody's happy.
How much work has gone into getting to this point?
Well, 6 years plus the preparatory period, you know, plus working through COVID. So, you know, the team, I'm really happy for the team, right? I mean, this is 1,000 people probably have been working on this mission from multiple contractors, the government, USGS, NASA, and under tough circumstances. And so I'm just thrilled that it went off.
Absolutely. I want to ask you more specifically about Landsat 9's two main instruments, the Operational Land Imager 2 and the Thermal Infrared Sensor 2. A little bit of a mouthful, but we have a quick video about those, and then I want to ask you about them.
Sure.
There are two instruments aboard Landsat 9. OLI-2 is all about light. Once in orbit, OLI-2 collects sunlight reflected off Earth's surface.
It sure would be nice
Light
if
passes through a set of filters to
we
separate
could
out
get
9
feeds that didn't
specific
have
wavelength
music
bands,
on them.
invisible and infrared frequencies. Each band provides different pieces of information about what is down on the surface. The second instrument aboard Landsat 9, called
I
TS2,
very much so
collects
am
thermal
looking
infrared
forward
wavelengths,
to the Artemis
temperature
era,
signatures emitted by the Earth itself.
which is coming right around the bend.
So that was a really quick breakdown. If you're a layperson
You could
like
almost
me,
say it's already started
because
because the Orion capsule is basically complete,
take
but
measurements and work together and then send it back?
I don't know. I don't
Sure.
think it'll
So
really
as
have
the
kicked
video
off
said, we have
until
two instruments.
until we
One
see the
is,
liftoff of the
looks at the shorter
SLS.
wavelengths.
What do you
And so
guys
it
think?
basically looks at light
Have
that
we started the
comes from
Artemis
sun
era,
and is reflected back off the
or
Earth
is it
to
still
the
around the
OLE2
corner?
instrument. The other instrument, TS2, looks at the
And
longer
yes, the
wavelengths,
first
which are
woman
sensitive
on
to
the
surface
moon. How
temperature.
exciting will that be?
And basically by combining the data from all
it's-
the different spectral bands, you can
It's
fingerprint
fantastic,
materials
and
on the Earth, so you can tell
so
what's
many other
vegetation, what's
milestones.
soil, what type of soil.
We're not just
And that's really
sending
what the
sending white
scientists
guys
use
this time.
the
We're
analysis
sending
that they do.
women.
And I
We're
also wanna
sending
ask you specifically
other
about the
ethnicities,
different kinds of lights
and
that
it's
Landsat
great to
collects.
see
We have another quick video to
diversification
explain that.
coming to the space
True color
industry
images are
here in the
made
United
by
States and
combining
around the
red,
world.
blue, and
I
green
mean,
light.
you know,
Combined
United
together,
Arab Emirates
these
announced
visible
their
bands of light make up all the colors in the
astronauts
rainbow,
recently,
and all of Landsat's
and
true color
it
images.
was very great to see that
Landsat
they
also
had
captures light that we
included
can't see.
both genders
That type of light can reveal some
in
incredible
their
things when you look
picking
at a false color
of
image, like the
of
difference
their
between types of
astronauts.
plants,
It'd
how
be
healthy
very
those
fun to
plants are,
see
healthy coral
that
reefs, and even
space
dead coral reefs,
program
fire
progress.
tracking, ocean pollution. The possibilities are nearly endless.
It has been a very
Okay, so
long
in that
time
clip,
since
we heard
anybody set
about
foot on the
visible
moon.
light versus
You're right,
non-visible
Liz.
light. I didn't even know
And
non-visible
it is
light was
very
a thing.
exciting
True
and
color
amazing.
versus false color. Again, didn't know false. There was even such a term as false color. So why do those things matter when you're interpreting data?
Right. So we really only can see 3 channels of light with our eyes at once, and so we have 11 channels on Landsat that we can put into any of those red, green, or blue layers to actually inspect. So a false color image is simply one where we take one of the infrared wavelengths that we normally can't see with our eyes, and we turn it into a red, green, or blue channel on an image.
That's a fair
to look
statement,
at.
Noah.
In fact,
That's a
when
fair statement.
people are actually analyzing their Landsat data, they may look at all 11 channels at once using something like an artificial intelligence algorithm on a computer. So actually looking at the image while
We've
it's
already
beautiful
sent
isn't
some
always necessary for getting the
some
information out.
test satellites and probes and
Landsat 9
things
project scientist.
that are part
Thank
of
you
the
so much
Artemis
for joining
program.
us.
We
hope
already
you
have
enjoy the rest of
the
your
Orion
afternoon, and
capsule,
I
which
think you
has
maybe deserve some
been
time
through
off
rigorous
after
testing.
that launch.
Yeah, great.
Congratulations to you. All right, turning our attention now to Landsat's imaging of the largest tropical rainforest in the world. Of course, I'm talking about the Amazon. It's nearly
it's
as
definitely
big as the
progressing.
continental United States. But every year,
Maybe we're in the
shrinking the
pre-game.
rainforest, and
We're at the
Landsat
tailgate
satellites
party
have been
for
documenting
the
changes
Artemis era.
since 1948.
Would that be a fair
1984,
statement, Noah?
The Amazon is the largest tropical rainforest in the world. At over 6 million square kilometers, the Amazon basin and the tropical forests that it holds are about the same size as the entire continental United States.
While we are
home to
watching
millions of
this
people
B-roll,
and tens of thousands of species.
I think it is time
Landsat is
for
NASA's
Astro Roadie to
longest
grab some
running
ice cream.
record
I
of our
will be
changing
right
planet.
back.
Data have been taken from Landsat satellites since 1972, and that allows us to go back in time over several very important decades. The Landsat archive is perfectly timed to capture many different waves of colonization across the Amazon.
It's very powerful in the sense because it's not just an image, it's actually a bunch of information. What happens with Landsat is that it have several bands which have specific information. So pixel by pixel, you have at least 7 pieces of information that can be combined in different ways to see different things. So if you are interested to see vegetation, there is one combination that you make that can give you more information about vegetation.
Landsat satellite data are the most important source we have about how much deforestation happens each year across the Amazon. 40 years ago, we see small-scale deforestation.
I'm going to leave my microphone muted while I'm eating so that I don't make all sorts of unpleasant noises in the microphone.
Commodity production taking hold. So today's deforestation across the Amazon frontier isn't a single family. It's tractors and bulldozers clearing large swaths of rainforest to make room for industrial-scale cattle ranching and crops. So far, the amount of area that's been deforested in the Brazilian Amazon alone is equivalent to the size of the state of California. Deforestation in the Amazon happens with fire. Today's deforestation looks like the large-scale clearing of swaths of rainforest using heavy machinery, and then the land is burned, and burned again, to remove all of the tropical trees and timber. If we think about the size of a soccer field, we think about deforestation in those same size categories. So deforestation in the early part of the Landsat record might have been numbered in a single soccer field. Today's deforestation happens in tens, if not hundreds, of soccer fields. The value of the Landsat archive is that we have a long-term memory of the changes that have occurred across the Amazon frontier. And the Mapbioma's record of land cover across the Amazon is an excellent example.
So Mapbiomas is a network formed by NGOs that works with science, universities, and startups in technology. Our mission is to map and monitor everything that is related to land cover, land use in Brazil, always with an historical perspective. Because back in 75, 0.5% of deforestation, less than 1%. In 88 was 5%. And now we are getting close to 20% of deforestation in the Amazon. You know, between 20 and 25%, what the science is saying that it's maybe the point of no return. And that's very fast, right? 40, 45 years to lose 20% of the Amazon. So we could precisely identify how many events of deforestation happen in Brazil, or what's the size, who is responsible, what is the piece of land that is there, if they have an authorization or not. And we find out that over 99% of all the deforestation that happened in Brazil in 2019, it was illegal. It's really kind of a striking information that make us to move and say, like, we can't accept, we just simply can't accept that we live on a place where the illegality is actually the norm, right? So this is like the type of thing that we want to kind of use the remote sensing data to kind of shake in the decision-making process of the different agencies in the public and in the private sector to take better decisions for what we call the stewardship of the management of our natural resources, which are crucial for all reasons in Brazil. The advantage of Landsat, first, is free. That's absolutely crucial for us. Second is that there's no other sensor, not even with lower resolution or high resolution, that will have a history consistent over the time for 35 years of image.
I think it all starts with
if you really want
little
to have
conversations like this where
of any process in the earth,
where we all talk to each other, and whether we agree or disagree, we allow each other to voice our opinions
and changing agriculture across a vast and important biome.
And it's okay. Like, it's okay to have a discussion without
All right, it is now L plus 27 minutes, 26
lynching
seconds
somebody.
and counting.
You know,
Let's go now to NASA Edge's
just because
Franklin
someone's opinion is
Fitzgerald
different than
with the
mine doesn't
Landsat
mean
9
they're
project manager.
wrong.
Franklin?
And if we can have those kinds of conversations with people,
who is the NASA project
our
manager
neighbors,
for Landsat
people
9.
in
How
line
you
at the
doing
grocery
today?
store,
I'm doing fine, thank you. Now, Landsat has been around
like
for
that's one
quite a
small
long
step
time.
towards
How long have you been associated with this
getting
project?
along in space.
Well, let's see. I started working on Landsat 8 back in 2005, so I've been working on Landsat satellites for about 16 years. And now the Landsat 9 project began in 2015. So we've been working on this satellite we're about to launch for a little more than 6 years.
Now, there has been a Landsat satellite in orbit continuously since 1972. That's a heck of a long time. How do you plan to keep the streak alive with Landsat 9?
Well, we're launching Landsat 9 to replace Landsat 7, which is run out of its orbit station keeping fuel. And so that's the urgency to get Landsat 9 up there so we can replenish the architecture of 2 healthy satellites, Landsat 8 and Landsat 9. Now, the history of Landsat is very interesting and sometimes chaotic. As you said, the first satellite was launched back in 1972, but NASA and USGS haven't had a stable budget line item through much of that time until 2014. And so now they have the Sustainable Land Imaging Program where they can plan for the future and develop future satellites. So the history in the past of trying to maintain that continuity of having 2 healthy satellites on orbit has had many ups and twists and turns and ups and downs, and the agencies have been directed down multiple different paths. Landsat 6 was even a completely commercial enterprise. Other agencies have participated. And so one of the reasons that this country has been able to
that was
maintain
yummy
2 active Landsat satellites on orbit for much of the last several decades.
Arm shake to finish off the ice cream.
Landsat 5 and Landsat 7 have lasted so long. Landsat 5 operated for almost 30 years. Landsat 7 has been operating for more than 20 years. And our USGS partners have just done a stellar job of managing the on-orbit assets and keeping them going. And but now we get to launch Landsat 9 up there.
Yeah, it would be nice to have
Landsat 8 and have
a new inspirational speech.
That sounds great. That is good news.
Or even a new inspirational speech giver.
Have there been any challenges to getting Landsat 9 in orbit?
Well, there's always challenges. Satellites, no matter what project you're working on, satellites are hard to build. They're always custom electronics and software and hardware and to do whatever mission you're trying to do. And so there's always technical challenges. And certainly in modern satellites, there's lots of bits and bytes flying all over and lots of electronics. And we've had our challenges with things like that, especially some bits and bytes and electronics. But I think clearly
the Artemis Accords are a good start towards that.
To launch in the middle of a pandemic. Developing a satellite is very interactive. Lots of meetings and gatherings to work through designs and design trades and testing and requirements and work planning for the future, working through risks.
It would be great if we could get everybody on board with the Artemis Accords. We've got quite a few.
People sitting at home in our pajamas,
we need more.
Wondering how we're going to complete this project. And this team has just rallied to be just a stellar group of people able to pull this mission together and launch it in the middle of the pandemic. The agencies and organizations involved have done a great job of building up the tools for working online and remotely. Northrop Grumman kept their doors open to keep critical work going on in the satellite while still, keeping people safe. And they also worked with us to be able to monitor test data separately or remotely. Our USGS partners expanded their ability to keep mission operations and ground system development going remotely. Our mission integration team that brings together the flight and the ground system put together new tools to enable testing all of this together. And still, there were lots of challenges with this. This has been tough on the team, and there's a stress level. You feel it, I'm sure, as much as anybody, that there's a stress with this pandemic, and it's been hard on the team. But and we've lost some schedule because of it, and there are other costs and whatnot. And we're still working through some of that. But I think that was by far
I
the
just realized the logo on my shirt has a little bit of green in it.
I'm so proud of this team bringing this mission
as
to
I move
launch.
around,
Yeah,
you can
still
see
here
through
in the
me.
middle of this pandemic.
Yes, well, it's a blessing to have you here. It's great to see the launch go off without
Maybe
any
it's cut
problems.
off on the
And again, thanks for being on the show with us today.
All right,
That's
thank
a
you
little,
very much.
little
Bill
lower.
Denstrom, NASA Project Manager for Landsat 9. Back to you, Marie.
Thanks, Franklin. The images Landsat 9
Okay, we're back to some more music again.
About gradual changes that add up over time. This Landsat will show us finer detail than ever before.
Landsat's entire job is to collect light. How intense that light is tells us about what's on the ground. You can think of intensity like shades of a different color. Landsat 9, the newest satellite to join the Landsat fleet, sees 16,384 shades.
The United States and China both have a long way to go as far as trying to cooperate with each other.
Detail in darker spots like coastal waters and dense
forests. It'd be nice to see
Joining
some
me now
olive
to talk about
branches
that is Dr. Pete Doucette of the U.S.
being
Geological Survey.
being offered,
As
but
you mentioned, USGS is a partner with NASA in the Landsat
we're not
program.
currently seeing that.
Now, Pete, you just heard that video with me about 16,384.
There's certainly a lot
like
less sticks and stones being thrown about now than there were in the previous presidential
much more advanced technology. Why is that level of detail, that number of
cabinet
shades, significant?
Well, quite simply, it allows us to see what the satellite is looking at greater granularities of shade. Obviously, the human vision system cannot detect that between that number of shades, but mathematical algorithms certainly can, and that's what we use our math algorithms to distinguish between subtle changes among landforms on the Earth, especially in vegetation and various kinds of soil. And so it has remarkable discrimination power to
So for those of you who are active on Twitter,
I also want to ask you about how
I
the
imagine
Landsat
there's
satellites work together.
something
Obviously,
that
they overlap a
will
little
make
bit.
sense
We have
with me
another
saying
quick video to explain
if
that.
you lose your cool and
Landsat
lose
9
your sanity
and its
on
sister
camera
satellite, Landsat
and
8,
you're a
8 days
content
to
creator,
image all of
maybe
Earth's land
don't
and coastal
upload the
areas.
video?
That means we get a complete
I don't know.
picture of Earth every
Just a
8
thought.
days. In this case,
I'm just
two
being told
satellites are
about
better
this in
than
my
one.
ear. I haven't seen it yet, but I imagine
Landsats 8
I
and
imagine
9 can
I
work
will be
together to
watching it
provide
after we
near
finish the
real-time
stream
data
today.
about what's happening on the surface of our planet.
So Landsats 8 and now soon Landsat 9 will be doing the job of surveying the planet 24/7. How long will these two be in orbit together? And then are there any plans yet for Landsat 10?
So great question. So Landsat 8 will continue in orbit.
They're not
until
going with
roughly the late,
they're not going with Landsat 10. They're going with Landsat
which,
Next.
At that point, Landsat
That's
Next, which
interesting.
is the follow-on mission to Landsat 9, right, is expected to replace it in orbit. And so Landsat 9 will, of course, continue into the 2030s is the expectation. And so together, as you saw in the video, these do provide a combined 8-day revisit, which is
What it was
a
like.
minimal threshold to meet to monitor what we refer to as sub-seasonal to seasonal changes going on.
And I understand this was also your first launch at Vandenberg. So what was it like to see, or should I say feel, the launch?
It was a great opportunity for me to witness my first launch, and I really want to commend all the folks at USGS and NASA for their dedication and passion over 6 to 7 years now of unremitting effort to make this day a reality. So it's really a remarkable accomplishment, and it speaks well to the Sustainable Land Imaging Agreement that we do have with NASA, which is a long-term commitment, right, to continue doing these kinds of Earth observations well into the future. And I guess this is a great opportunity to kind of renew those marriage vows, in a manner of speaking, between NASA and USGS. And we even had a little bit of fireworks to go along with it.
Absolutely. Well, so glad you could be here to enjoy the launch. Congratulations to you and the USGS team, Dr. Pete Doucette. Thanks again for being here.
Thank you very much.
All right, we learned earlier about how Landsat documents deforestation in the tropical rainforest. Now to the coldest places on Earth. Time-lapse videos of glaciers and ice sheets, as seen from space, are giving scientists new insights into how our planet's frozen regions are also changing.
From an observational standpoint, we're at a sweet spot where we can see many different aspects of the changing ice cover. And so the problems are then moving toward understanding what we see changing, it is pretty clear that we're going to understand what the ice is doing. I think that observational glaciology in terms of remote sensing is a very data-rich field now compared to 1972 when you had a few images. So we are beginning to get a historical record of the speeds of glaciers. And so we can watch how rapidly that surface is lowering as things speed up, or where it's thickening, and where the surface is actually coming up, where ice is actually thickening on land. With this record, we can go in and look at the speeds of ice flow over decades and how it's been changing. The reaction I get from other people that study glaciers is that I watch these videos too fast.
Battery changed.
I like to see the fluid nature of the ice. It lets you see the ice on the land as sort of this very active participant in what's going on. One of the places that I like to look at in this particular video of Hubbard is if you look just to the upper left off the 5 kilometer scale bar, you can watch the edge of the glacier just spread across the river bed that's coming out of the glacier that's adjacent to it. And it just moves. It moves trees. It moves all sorts of material every single year, just advancing. So this video that shows the Walsh Glacier on the top and the Logan Glacier on the bottom, these are huge glaciers. They're the order of 4 kilometers wide or so. What we see as we loop through it is that the flow in both of these sits there for years, and then it will undergo a pulse of faster motion and then sit there again.
Yeah.
What strikes me about this image
of crossed the halfway point of the weight?
Nature, which is
I
that
think
it's a
we
large
might as well
puddle
just
of
finish
ice.
it out.
You've got huge glaciers that are flowing down out of a really high mountain range. And these big glaciers reach the coastal plain, and the ice just spreads out in this big puddle, like you'd taken a bottle of syrup and just dumped it in the middle of a plate. The Malaspina is sort of that big pile of syrup. The other thing that you see is that the ice coming in will head either to the left or the right of center for a while, and it will string out those moraines so that they get bent into these loop shapes. And it wasn't until I saw this video that I felt like I had a good understanding of just what was producing these amazing loops in the moraines. In compiling this Landsat record from Landsat 1 in 1972 up through today, I've gone through year by year, and I've tried to pick out the latest melt season image I can. So the white snow of winter is gone, and you can see the detail and the flow stripes and the crevasses in the ice, and build annual mosaics that give us an image of all of the ice in Alaska and the Yukon. And when those are all lined up, all 48 of them are lined up and played as a movie, we can see the behavior of the ice over nearly half a century. Having such a long record allows us to discern long-term trends and separate them from the kind of behavior you might get with a couple warm or a couple cold years. To have a persistent observational
Very interesting footage
that's been in place ever since the first Landsat was launched, it really gives us a much better view of this really rapidly changing part of our planet.
The first Landsat satellite launched in July 1972. It would be the start of the longest data record of Earth's landscapes from space.
From 438 miles above Earth's surface, the newest Landsat satellite will collect data so detailed it can detect both natural and human-caused changes to the landscape. But what really makes Landsat unique is the half-century of data, an unbroken chain of observations over 5 decades. Let's take a look at how we got here. 1966, the U.S. Geological Survey proposes a satellite to study Earth's land masses. But what would that look like? Over the next few years, USGS and NASA researched their options. 1970. NASA gets the green light to build an Earth Resources Technology satellite, an experiment to study and monitor our planet's land surface from space. Launched in '72, this was the first digital data of Earth, repeated at regular intervals with geometric fidelity to allow comparison between observations. This changed how we drew maps, tabulated agricultural production, and assessed damage after disasters. In 1975, NASA launched a second satellite similar to the first. Now they were collecting twice as much data. With Landsat 3 replacing the aging original in '78, focus shifted to the advanced technology planned for the '80s. The Thematic Mapper instrument, launched on Landsat 4 in 1982 and on its twin Landsat 5 in '84, was a major step forward, collecting 7 different wavelengths at better ground resolution and with
I'm glad
higher
NASA
precision.
put together
This was
the
beating heart of the satellite and became the workhorse for a
presentation that they're giving us here for the hour-long wait for
red, green, and blue,
satellite
allowing
deploy.
natural color composite images. With the addition of shortwave infrared wavelengths, the data could better highlight flooded areas, mineral deposits, and burn scars from wildfire. The thermal bands were also upgraded, allowing individual farm fields to be tracked. The 6th Landsat was intended to be another big step forward, but it never reached orbit after launch in 1993. Plans immediately began for Landsat 7, which would carry an even more improved sensor.
Definitely gonna see some
At the
copyright
time, the Enhanced Thematic Mapper Plus
copyright
was the most
issues on
stable
this
Earth
video now,
observation
that's for
instrument
sure.
ever sent into orbit, and the calibration could be updated while in space. For the first time, we had an instrument robust enough to collect lots of data, and we had a plan to thoroughly record the entire globe. Landsat 7 was put to work mapping coral reefs, and even produced the first high-resolution natural color map of remote Antarctica. Improvements to the thermal bands on Landsat 7 allowed states and counties to gauge how much water was used by crops. This helps them manage water resources efficiently. An important milestone occurred in 2008 when the USGS made the data available to download for free. Users were able to get the data they needed and not just what they could afford. It really unlocked
Giving
a ton of
information
innovation
out
and
for
created
free
about $2
creates
billion a year in
economic benefits.
The modern
That's
era of
an
Landsat observations
interesting
began with the launch of Landsat 8 in 2015.
result to giving
Having
away
a push broom style sensor on
expensive
Landsat
data.
8 was a big improvement over the older scanning sensor. The Landsat 8 ground system that USGS runs is capable of receiving a lot more data than before. We're downloading over 725 scenes each day. That just wasn't remotely possible until Landsat 8. The 2 European Sentinel-2 satellites were designed to mesh with Landsat so that users can treat data from all the satellites as if it came from one single source. Now we get observations every 2 or 3 days instead of every 2 weeks. 2021 is the launch of Landsat 9, the next step forward. It will collect the best data ever recorded by a Landsat satellite, while still integrating seamlessly with the extensive archive. Since the early 1970s, Landsat satellites have allowed us
All right.
to better manage our resources.
I need to go and stretch
Landsat
my
data
legs.
has enabled countless innovations,
and I
and
will
let us track
return.
the effects of climate change into the future.
Over the past 50 years, Landsat satellites eventually run out of power and need to be replaced by another, newer Landsat satellite. But NASA is currently working on a new technology to refuel dead satellites in order to extend their lifetime. Let's go back to Daryl and Mick with more on this exciting new mission. Daryl?
Yeah, that's right, Marie. The target satellite is called Landsat 7, and it has enough fuel to let it last the rest of the year. Beyond that, it's going to run out, and its orbit will begin to decay. And when that happens, Mick, it's impossible for it to continue the mission.
Yeah, you're exactly right. Satellites are designed for a limited life, a mission life, and Landsat 7 is coming to the end of its life as far as orbit-keeping fuel. So that is going to be an important thing for us to look at in the future, how we can maybe help these things.
Well, and that's why NASA is exploring some new technology called OSAM-1. It's a pretty cool spacecraft. It stands for on-orbit servicing, assembly, and manufacturing mission. It's being built. It is designed by engineers at Goddard Space Flight Center, and it's pretty cool because it'll be the first time that we will see a robotic refueling in space.
Landsat 7 was launched in 1999 from Vandenberg Space Force Base. And since going into orbit, the satellite far exceeded its 5-year mission lifespan. But now it's running low on fuel. Instead of becoming yet another piece of space junk, Landsat 7 has a new mission. As the host satellite for an on-orbit refueling spacecraft called OSAM-1, which stands for On-Orbit Servicing Assembly and Manufacturing 1. Here's how it'll work. Landsat 7 will lower its orbit while waiting for OSAM-1 to launch. Once in space, OSAM-1 will autonomously rendezvous with Landsat 7. And when OSAM-1 gets close enough, the robotic arm will attach the gripper tool from off of its payload deck. With a shoulder, elbow, and a wrist, the robotic arm has a range of motion similar to a human arm, making it ideal for this complex and dexterous mission. OSAM-1 then catches Landsat 7 by the Marmon ring, which is how it attached to the rocket when it launched. Once ground operators nestle the satellite onto OSAM-1's 3 berthing posts, the autonomous pit stop in space begins. A cutting wheel removes the thermal blanket off the original fuel valve panel, which was never intended for a refueling. Ground operators will then use OSAM's advanced tool drive system to prepare the valves. The first will cut the lock wire that secures the valves. Then a removal tool will spin the cap off and stow it safely on the servicer. Now it's time to fill her up. The Hypergol refueling tool is connected by a hose to an onboard fuel tank. So when the nozzle is guided over the original fuel valve, more than 100 kilograms of hydrazine, similar to jet fuel, will be pumped into Landsat 7. The on-orbit refueling is expected to give Landsat 7 enough fuel to safely deorbit to make way for future science missions.
And that extra fuel will allow Landsat 7 to continue on and re-enter Earth's atmosphere, which is important, keeping space junk clear out. That'll send it back down into Earth's atmosphere where it will burn up. And then that, Mick, makes way for another spacecraft to then take its place in that orbit.
Absolutely, Daryl, and that'll be able to keep things going in the future. I just think that's some cool technology that NASA's working on, that we'll be able to do something in the future with that, not only refuel a spacecraft, but maybe even do some manufacturing in spacecraft. That would be really cool technology that we could use for future missions.
It certainly would, and of course Launch Services Program, whom you work for, is going to be finding a rocket for this spacecraft. What can you tell us about that?
Yeah, so OSAM-1 is on our current Flight Planning Board manifest, and we're looking at around January 2025, and we are working through all the requirements right now. And as you said, we will broker up and match OSAM-1 with the right rocket that is needed so we can get it on its way to help out Landsat 7.
And you can see how important this is to the future development of and exploration of the moon and Mars. You got to have robots in order to build stuff.
Yeah, absolutely. As we look forward to send humans back to the moon and then Mars, right, robotic demonstration missions like this are crucial so that we can build things in space, repair things in space, do other type of things in space. So very excited to see this kind of technology being developed across the country. And then, of course, Launch Services Program launching and it's on its way.
That's right, and you guys are on top of it. I want to talk a little bit about the mission. We are currently at L plus 52 minutes. Here's a look at the graphical animation of what Centaur is doing right now with Landsat at the front. You're looking, it's pointing down. You see the nozzle up. You see Landsat 9 at the other end. Of course, it's an animation, but it's real-time data. It's taking data from the telemetry to show its representation in space. And currently, there's a reason why it's positioned like that. Tell us.
Yeah, so that we can keep the fuel on board as we get ready towards the front of the Centaur, as we get ready to prep for Landsat 9's separation, and then moving on to our next part of our mission, which would be main engine start 2 for our CubeSat deployments later on in the mission timeline. So far we've heard from Patrick Moore as they continue to look at this data. that everything looks great, and the Centaur and Landsat 7 are on their proper trajectory.
That's right. And so for now, though, we've got to focus on Landsat 9's separation from Centaur. And as you can see at the bottom of your screen, we're about 27 minutes away from that and continuing to count down in that direction. Landsat 9 is just one part of the larger Earth science mission here at NASA, and the woman leading it is NASA's Karen St. Germain. Our own NASA Edge's
yes,
Mr.
we have an
Fitzgerald,
interview with
Fitzgerald,
Rogue
is there
Space
with her
available
live.
on our
Take it away.
channel. We
Yes,
do a lot
thanks,
more
Daryl.
than just live streams. We have a lot of
I'm joined by
interviews. We
Karen
have a
St.
lot
Germain,
of
who is the
short
director
form
of
content,
NASA's
medium
Earth Science
form
Division, as
content,
you've said.
and
Karen,
longer
thanks for
videos
joining
as
us
well.
this afternoon.
Great to be
So
here with you, Franklin.
if
Now, I
you're
understand you
new
were on
to
console
Total
during the
Space,
launch. How were things from your
give
point of
that
view?
backlog library
It's
a little bit of
always an
a
enormous
look
thrill
over.
to be on console for a
Maybe
launch.
Mr. Producer could
And,
link
and
the
today was no different. It was a beautiful,
Rogue Space
smooth
interview for
launch.
us. That was a great little
But in
interview
addition
with
to that thrill, when I'm sitting on console, I am
with
representing the hundreds of
Miko
engineers and
on
scientists
Deep Dive.
who not
Interviewed
only
them.
got us
I
to where we are
believe Rich
today for
was
a
on the
launch,
call with
but
them.
these
I
are the
can't
folks who
recall.
will activate the instrument and then take the data that the instrument collects and
it
turn
was
it
another
into
space nut.
real actionable information. So it's not only a thrill, but it's humbling. It's an honor to be representing all of those folks on console today.
Now, speaking of data, let's talk about Landsat's longevity record. How do we use Landsat to understand the human impact on the environment over a long period of time?
Yeah, so Landsat data is unique in the world. This is the longest data set looking at land, and when we look at that at a time series of that data, we can see changes in agriculture patterns, in forests, in urban environments. We can even see changes in the coastlines. And many of these are impacted by climate change. So that record helps us understand not only that change is happening, but how fast and whether it's accelerating and what it means for humans.
Disaster mitigation is a huge topic of interest with wildfires ravaging California year after year, and 2020 being on record for the most named storms coming through. How does the data from Landsat help our government to respond to these disasters?
Landsat data is critical in every phase of a disaster. Prior to an event, Landsat data can help us understand the risks. So, for example, if we have a forested area where the forest is no longer healthy, that can indicate that vegetation is fuel for a fire and is ripe for a wildfire. That can help planners and responders prepare, and then while a fire is happening, we can see it from space with Landsat and our other systems, and then after a fire, we can see the burn scars, which are important because that can be the location
Coming up on
of
24 minutes until
does come later.
we have satellite
So it's in all
separation.
phases of a disaster that Landsat can help us prepare, mitigate, and respond, and recover.
That sounds great. Karen, thanks for being with us this afternoon.
Thank you. It was great to be with you.
All right. Marie, back to you.
All right, thank you, Franklin. If you're just joining us, we had a spectacular launch this morning in California. The marine layer cleared
Yes,
just enough
we
for us
are
to see
definitely
liftoff
going
4
for a
miles
barbecue
behind us.
with Rogue
And
Space.
NASA's Landsat 9 Earth observation satellite lifted off here at Vandenberg Space Force Base atop an Atlas V rocket. That was at 11:12 a.m. Pacific
The
time.
CEO,
and
Jeremy,
it,
was very,
reached orbit,
very
just
interesting to
minutes
talk
ago. And in about 27 minutes or so, we expect to hear confirmation of spacecraft separation as the satellite orbits 438 miles above the Earth's surface at nearly 17,000 miles per hour. That's a view from a little bit earlier today of liftoff. The satellite will capture 700 images per day, building on the last half century of Earth imaging data that has revolutionized humanity's ability to manage resources and respond to climate change. Landsat data is also being used to help resource managers find algae blooms in America's lakes. Here's a video to explain.
I remember when that happened.
It's really an amazing little critter, and it's been around for over 3 billion years. In 2016,
Utah State University,
Utah Lake
that
exploded
is
in cyanobacteria blooms.
a stone's
The
throw
problem is
outside
that
my back door.
Many cyanobacteria produce toxins.
You may have heard it called blue-green
I
algae,
bet I've seen
but
her
it's
at the
really a
grocery
kind
store.
of bacteria taking in sunlight to drive photosynthesis and giving off oxygen.
It actually requires quite a bit of lab testing to know whether or not it's a harmful algal bloom. And what we're really worried about is people and pets ingesting that cyanobacteria.
Dr. Kate Fickus is a harmful algal bloom scientist at Utah State University. She helps the Utah Department of Environmental Quality track conditions in lakes and reservoirs.
So Utah is the second driest state in the nation. Most of our major lakes are actually man-made reservoirs. They're heavily used for recreation. They're heavily used for agriculture. And they're really important to the state as a resource.
In 2017,
couldn't go
harmful
swimming
algal
in that
blooms
lake or
returned to
anything.
Utah Lake. This time, officials used satellite data to identify troubled locations. But how can instruments up in space tell us about microscopic organisms in a lake down on Earth? By measuring their blue-green color. Landsat collects light in visible and infrared wavelengths. Cyanobacteria reflect more green light than plain water does, allowing Landsat to identify algal blooms.
From satellite, what we see is basically that primary pigment, which is chlorophyll A, but the color by itself could be misleading. A nice
Those are some
picture
beautiful shots.
is not necessarily providing a set of quantitative data.
Algal blooms can look beautiful from space.
Look at that.
But the numbers
That's
behind
just
the
an
images are the
amazing
important
picture.
part.
Each measurement is highly accurate, and it's very much corresponding to the number of photons that are leaving the body of water, which could be related to the biomass and the amount of phytoplankton.
Dr. Nima Pahlavan is working with NASA and the U.S. Geological Survey to make sure Landsat users have consistent, accurate, and ready-to-use data about lakes and rivers. Water is difficult to
Leveled
study
up.
from space because only a fraction of the sunlight is
Even NASA
reflected
plays
back to the
video
satellite.
games.
But engineering improvements on Landsat 8 have leveled up its ability to measure the small signals from water bodies. After Landsat collects the data, it gets beamed down to the USGS Eros Center, where it is archived. The raw numbers pass through checkpoints to align the geography, correct for sun strength, and then compensate for the effects of the atmosphere.
So you essentially removing those atmospheric scattering and absorption.
Let's break down what NEMA means here. To measure the amount of cyanobacteria, you need to know how much light reflected off the surface. But some of that light gets scattered by molecules in the atmosphere on the way to the satellite, lessening the signal received. And sometimes light that never made it to the surface gets scattered into the satellite, adding a false signal. Like removing the haze from a photograph. Atmospheric corrections leave you with a quantitative measurement of exactly how much light left the water, known as aquatic reflectance.
You want to look at the actual physical measurements to derive physically meaningful products from satellite data.
And that's the goal, to transform the raw materials into finished products so that end users don't have to build it themselves.
By providing aquatic reflectance products, you're majorly reducing the burden on satellite users.
Although it is still provisional, NEMA's aquatic reflectance data product is available for download from the USGS. Scientists like Kate Fickus convert the data product to maps showing the amount of chlorophyll A, helping local officials pinpoint where to test for toxins and warn residents.
I use Landsat and other remote sensing technology to help local health departments understand where there's a bloom, the magnitude of the bloom, and the size of the bloom.
The spatial detail is another benefit of using Landsat data. Each pixel is only a 30-meter square, the size of a baseball diamond. Yet it collects data across a broad area. In other words, there is a lot of data at a fairly high resolution.
With Landsat, we can get into some of the marinas that are popular fishing and swimming spots in order to inform local health departments about making public health decisions.
For the 2017 outbreak, that's exactly what happened. Satellite data gave an early warning to local officials in Utah. The extra week of warning saved hundreds of thousands of dollars in healthcare costs. Monitoring algal blooms from aquatic reflectance data is just one example of benefits from Landsat's data products. Wildfires, snow cover, vegetation health, temperature, and more are available for every spot on Earth. Landsat's highly calibrated data products, free to download and use,
just under 18 minutes until
more accessible
we have
to
satellite
users,
separation.
bringing a greater benefit to society.
One of the experts we just heard from in that video is Dr. Kate Fickus, and we are lucky enough to have her with us today. I've been so looking forward to this. Kate, thank you so much for joining us.
Thank you, Marie, for having me.
Besides being an expert on algal blooms in our country's lakes, you also are the co-founder of the Ladies of Landsat. We talked about that earlier in the show, paying homage to Virginia Norwood. But tell us, what exactly are the Ladies of Landsat?
Yeah, the Ladies of Landsat are a group that I started in 2018, and really the goal of Ladies of Landsat is to increase diversity, inclusion, and equity for women and other underrepresented scientists in the field of remote sensing Earth observation. So we do this through a bottom-up approach, calling for amplification and representation of those women and minority scientists, and then a top-down approach, so asking leaders who have the power to make some change in the status quo or the dynamics and leadership in the field of remote sensing to help us out, get more women involved in remote sensing in those higher up positions.
Why did you feel it was so important to start this group and to make it an official group on Twitter?
Yeah, I've been a remote sensing ecologist for about 10 years now, and I would travel the world, go to international conferences. I didn't see many other women. I kept asking the question, where are all the women in these remote sensing and Earth observation sciences? So I started a Twitter group, and then I found my dear friend and colleague Maureen Crowley, and we
My
saw
sister
the same
entered
thing
a poetry competition
underrepresented
that the prize
scientists
gets to
find
go
a
to
place
Ireland
in this community.
for
It's generally
some
dominated by men.
language
That can
studies
feel lonely, scary.
for a week or
It can lead to
two.
a lot of women dropping out of science, and especially remote sensing. We didn't want that. We wanted a place to be inclusive and a community to support each other.
Well, as a
My
mother of
sister
2
has
daughters,
actually
I'm
done
really excited about the work
language
your group does,
studies in
and the example
Ireland
that you set for my kids. So thank you.
for
I know
part
you're
of her
also
schooling
gonna get to
already,
meet
as
with
well
Virginia
as
Norwood a little
Quebec,
bit later.
if I
She
remember
wasn't able
correctly.
to join us here on the show, but I want to
could
ask
be
you,
mistaken on
what
that.
do you want to say to her?
I have
think
so
I'm
much to say to
mistaken.
Virginia, but I think two things
was
really
something else
stand
she
out.
went to
First,
Quebec
thank
for.
you. You know, Virginia was able to walk so that Ladies of Landsat can really run nowadays, although she was running back in her time as well. But she provides an anchor to prove that Ladies of Landsat have been part of this Landsat program from the very beginning. It's just maybe taken about 50 years to really find our voice and show that we're here to stay and we have a lot of power. I think the second one is congratulations still 50 years later after she invented the MSS without the support system or a community to back her up of Ladies of Landsat. Back then she was a trailblazer, and that's just phenomenal. I'm so impressed.
Me too. Yeah, when I read about her, I was like, wow, she is literally a hero. What do you want to say to women, not just women, but underrepresented groups? I mean, that's your target audience who are looking
Wine
for
on the
and how can they
moon.
find you?
Well,
They can find Ladies of Landsat on Twitter, and I always
that
say
would
if
be
you're a
very
Lady of Landsat,
expensive.
you're in if you want to be a Lady of Landsat. So find us on Twitter, follow, like us, and you're
It
in.
would
If
either
you need
cost a lot of
support,
money
if
to
you need
ship a
help,
bottle up
we'll
there,
find somebody to help you. We're
or
always there
it
for
would
you.
cost
We want to be
a lot of
collaborative
money
community and
to
choose community over
send the
competition
resources to be able to
All right, Dr. Kate
grow
Fickus, thank you so much for
something
joining us.
in order to
We
make
have
wine
covered
out
a
of it
lot
on the
today,
moon.
but there's more. Landsat is even helping rescue an endangered
Definitely
species
possible.
of bird in the western United States.
I would assume that fermentation techniques would work as long as there is at
We
least
took
some
freely available
gravity.
Landsat imagery and we developed this range-wide model that covers a vast spatial extent and a really
Even
wide
if it
temporal
was
window to develop these
centrifugal
fine-scale maps
gravity.
of habitat suitability for an endangered species
Gravity.
in an environment that's changing all the time. So I'm a research biologist / project manager for the University of Idaho, and I work on this endangered ridgeways rail in the southwestern United States. It's a species that needs attention. It is an indicator species of marsh condition throughout the whole Colorado River system. I know they're a marsh bird. They're like the size of a chicken.
I was trying to get a look at that
high up
parrot.
the food chain in these marshes, and so
there it is.
If rails are doing well, it's indicative.
By the time I tried to look earlier,
so
they had
develop
gone
products
to
that help
cut to a
us
different
manage
shot.
marshes for
So
the rails, it's also going to help protect habitats for other species.
you can tell they filmed this over a period of time. That bird's in a different position every time they pan over.
And we were really focusing on, okay, how do we take effective tools and apply them?
Where's the bird going to be next? Is it going to be facing a different direction? I think it will be.
So we paired this spatially extensive on-the-ground sampling data with really extensive.
That's a good one, Noah. Yes, there will be
range-wide habitats.
There will be cheese. Probably quite a big wheel of cheese.
Throughout the range of the species.
If Elon Musk has anything to say about it.
We needed a product that was accessible, available, covered our area of interest, and our time frame of interest, and Landsat really fit that perfectly for us. And we built this tool that is accessible to managers, and they can view it, and it's updated
the bird's
annually,
gone
so
now.
they'll have up-to-date predictions of habitat suitability throughout the entire range of the species, so they can really focus in on the areas that need management, that don't need management,
inside
that perhaps need on-the-ground confirmation.
Oh, look at that guy's barely visible.
It should be a powerful tool to more effectively and efficiently allocate limited resources to ideally one day get this species fully recovered.
We want to go over again to NASA Edge's Blair Allen. He is standing by with a special guest.
He
from the
couldn't
US
even say
Space
it with a
Force
straight face.
to tell us about a secondary payload on this mission. Blair?
How come he's not wearing the new uniform?
Joining us now is Major Julius Williams of the United States Space Force. Major Williams, can you tell me a little bit about what your role is for the Space Force?
Yes, first, Blair, NASA.
I love the fact that we have a Space Force here in the United States.
Is part of the launch
Can we
enterprise
please
and
rename
Space
it?
Systems Command
Can
down
we
at Los Angeles Air
please
Force Base.
give it
We essentially survey
a
all
legitimate
launch
name?
opportunities, whether it's DoD, civil, or commercial, to look for the extra performance that's on the launch vehicle to get other small
We've
satellites.
given them a
and larger
meme
satellites to
name.
space.
I'm glad you mentioned
And
small satellites, because that's actually part of why we're here
just
today. Landsat,
can't
the main
listen to
mission,
anything they
but
say
now
with
also this
any
lesser-known mission
seriousness.
launching microsatellites or CubeSats. Can you tell us about it?
Yeah,
To
so
space
the
and
L9
beyond.
EFS, that's the Landsat 9 ESPA flight system, was essentially a joint partnership between the former U.S. Air Force and the NASA Goddard, but now the
my
Space
goodness.
Force since 2019. So the ESPA flight system team, part of NASA Goddard Space
and
Flight Center,
it's no one's
the U.S. Space
no one
Force and
in
Parsons
that
Corporation
branch
was
of the
essentially a joint
military's
effort
fault.
to take an ESPA
It just
Grande
was
ring and essentially, or ESPA ring,
previous
sorry,
administration
and
gave
build
it the
out a
worst
system
possible name they
that
could
fly
come up
to
with.
18 CubeSats, and we are flying
It's
4
like they had watched a little bit too
That's
much
awesome. Now you talked about a
cheesy
very
television.
complicated process. but
Good
it's a very
cheesy
important
television,
one.
but
How
still
do you
cheesy
actually
television.
launch these CubeSats from the rocket?
Yeah, so there's a various ways to do it. Depending on the rocket system that's flying at that particular time, we've had successful missions where we've flown it on the aft end of the aft bulkhead carrier. On this particular one, as I mentioned before, in a ESPA ring, we are actually taking dispensers like this one right here. This is a nanosat launch adapter system. And at the point of time of the launch, this door would actually be closed, of course. But when it gets time for the actual deployment, an electrical sequence and a lot of other different variables that will happen, so that way it actually opens up, and then the satellite at that point in time will dispense and deploy at this desired time.
You know, it's very exciting to look at this CubeSat technology. So I'm wondering, can you tell me,
Yeah, that
how
TV
does this
show.
kind of innovation help the Space Force in
That
the
TV
future?
show was
A lot,
bound to
because
happen
whether
when
it's
they
the
were
Space
given
Force
the name
for
Space
science and
Force.
technology, R&D,
And I
prototype missions,
loved
and
that.
a lot of our critical operational capabilities that we
The
need
the
to get
main
on
character
orbit.
is
A
not
lot of
one of my
satellites
favorite
are
actors,
going down from the larger,
but
well-known systems down
the
to
name
small sats
Space
or
Force was
CubeSats or
begging
ESPA-class size
for
satellite
that
vehicles.
show to happen.
So being able to use the
And
multi-manifesting capability, also known across community as rideshare, gives us the ability at a
like
cheaper cost to benefit to the taxpayers'
it,
dollars
it's
and everyone
almost
involved
embarrassing
to
to be an
essentially
American
mount up
with
dispensers like this,
a
load them
branch
up
of the
with
military
CubeSats, ranges from various sizes up
named
to a ESPA
Space
size,
Force.
and then get it on orbit. So that
I
technology is going to be critical
I
as we
I can
continue
barely
to
keep a
build
straight
out
face
some of our
while I'm
national
talking
security
about
space
it.
launch missions.
And it kind of helps you develop it kind of a la carte, right? Because you can do it in a very small footprint.
Exactly, a very small footprint, and if it's the same form, fit, or function, we actually have the capability to
Stuart,
switch
I
out
take it
those
you're talking
satellites
about
if
the
we need a
bird.
critical capability that needs to get on orbit to meet whatever the requirement is at that point in time. Then we can actually down to L-4, depending on the mission at that point in time and the variables at play. We can actually swap out those satellites, especially with it being a CubeSat size.
I'll tell you what, we're very excited to have you
Go
on the show
Space
today.
Force.
And wish the best of luck to you, the Space Force, and the CubeSat program and the CubeSat launch.
Yes, and we're looking forward to it. So about 2 hours or close to an hour after the fact, 2 hours and 14 minutes, we'll deploy these sequences out there and look forward to seeing the capability.
I don't know what I would call it.
Go CubeSats,
I really
go
don't
Space
know,
Force.
Noah.
Thanks so much, Major Julius Williams of the U.S. Space Force. Back to you guys.
All right, thank you very much, Blair. And back inside the Mission Director Center, we are tracking Landsat 9 and Centaur. Which
I don't know. I've thought about it a number of times, and I haven't really come up with anything all that great.
Bar, we're just a few minutes away,
but
from
almost
the
anything
actual separation.
would be an
very excited
improvement,
about
I think.
this, getting ready to separate.
Call me
Landsat 9
judgmental.
and
Maybe
continuing
I'm
the
being
Landsat
just being judgmental.
Excellent
here, but
launch today, and I'm just waiting for that moment when we hear.
I think any number of things
It certainly
would
was
be
beautiful
quite a
from
bit
our
better
vantage point. We've got a lot of
than the
cameras
name
here
it
that were
currently
watching
has.
it, and it was an enjoyable launch to see. But Mick, it's just the first of many launches.
If
as
I
we go
somehow
through the end
managed
of this year, let's take a look at a
to
preview.
leverage myself into a situation where I had the
Since
opportunity to
1998,
rename it,
NASA's Launch Services Program, or
I
LSP,
would do so.
has served as Earth's
Absolutely.
bridge to space.
Unequivocally.
Based at NASA's Kennedy Space Center in Florida, the program matches scientific and robotic spacecraft with launch vehicles for some of America's most inspiring space missions. Our mission, to successfully place spacecraft in orbit around the Earth, the Sun, and destinations deeper into the solar system. We centralize NASA's launch services while addressing state-of-the-art customer needs. But LSP
I
does more
think
than
on the
pair
ISS,
spacecraft
your
with the
sense of
appropriate rocket.
smell
The
is
diverse
more
group of
relative
government
to
and
being
contractor
in
engineers,
an
analysts,
enclosed
and
environment
advisors certify
where you
rocket
become
performance and
desensitized
reliability. The team
to
provides
smell
long-term
because
technical
anything you're
expertise and
smelling
support to
is
spacecraft customers
ever
from
present.
around the world.
But yet,
The team
if
manages
the
launches
general
from
smell
multiple
of the
sites,
cabin
depending on
changes, you
customer
do
and mission needs.
detect
Cape Canaveral
that.
Space Force Station in Florida.
We noticed rather
Vandenberg Space
recently
Force
they had a
Base in
little bit of
California,
a
Reagan test site at Kwajalein
smoky
Atoll
fire
in the
problem
Republic
on the
of Marshall
ISS,
Islands,
and the
and
astronauts
Pacific
did
Spaceport
detect that
Complex
smell with
in
their
Kodiak,
noses. They did
Alaska.
make comment
Building
about
off
it.
of
So
past success,
the
LSP forges
diminished
ahead to
sense of
support
smell,
NASA's
yes, but
future.
I
The
think it's
program
more
has
just
4
being in an
upcoming
enclosed
missions in
space
2021.
that
Leading off
that takes
LSP
place.
slate is Landsat
Taste,
9,
I don't.
launching from Vandenberg. A partnership between NASA and the U.S.
I'm really
Geological
looking forward
Survey,
to
the mission will monitor and
to
manage
this
land
mission they're
resources
going to
to
talk about in
sustain
just a
human
second
life.
here.
Next up,
I'll wait
launching
till
from
there we
Cape
go.
Canaveral Space
Lucy.
Force Station,
I
Lucy
really am
will be
looking
the
forward to
first
that.
mission to study Jupiter's Trojan asteroids, which may be remnants of the primordial material that formed the outer planets of our solar system. It's then back to the West Coast for Double Asteroid Redirection Test, or DART, NASA's first planetary defense mission. That will be followed by Imaging X-ray Polarimetry
So many
Explorer,
fascinating
or
science
IXPE,
missions coming up
launching from Kennedy.
in
IXPE
the
will
somewhat near
expand
future.
our understanding of X-ray production in objects such as neutron stars and black holes. Years of testing, determination, and dedication, working as one.
I
NASA's
don't,
Launch Services
going back to where I was,
is Earth's
sense
bridge
of
to space.
taste, I would imagine
Well, there you saw a preview
that
of some of the exciting moments that are coming up for LSP.
eating the
and
food that
let's
they
talk about
have
the
available
next
to
one
them
up
up there.
is Lucy.
Yeah, Lucy launching on the east coast
You
of
probably
Florida.
get to
We're
a point
excited about
where
Lucy.
you've eaten the
Just as
same
much as
thing
we are
so
Landsat
many
9
times
today,
that
but Lucy, planetary
you
mission,
don't want to
going
taste it
study the
anymore
Trojan asteroids out by Jupiter.
until
That is
you get
so
that
exciting. Some
next
cool
shipment of
science is gonna be
fresh
going on there.
fruits and
You and
veggies,
I just actually spent a few minutes
you're
with
able
Dr.
to do
Z,
some sort of
hearing a little bit about
live
that and his
vegetation
excitement
growth
too.
or something on
We
the
are so
station,
excited
which
to get
they've
back
done
to
a number
Florida.
of
And then turn right around and come back here to Vandenberg
growth
to launch
experiments
the
up
DART
there
mission,
and been able
which
to
I
eat
think is
fresh
an awesome
space
mission
grown
also, from an
lettuces
aspect
and
that we are
things up
doing a
there.
technology
So
demonstration for defense, that we're going to impact a satellite into an asteroid to see if we can change the course of an asteroid
That one's impressive.
That we are just doing some cool science. It's not just LSP that's excited about these launches, but NASA in general as an agency, and we're just hoping everybody out there is excited about these upcoming missions as we are.
And we have a link for you if you want to find out more about the Lucy mission, which is the one right around the corner on October 16th. You can see it there on the bottom of your screen. Just go to the web address, nasa.gov/Lucy. Again, we are targeting October 16th for that launch. Time now until separation.
I think that's
We're
worthy
dealing
of
with
a
little bit
comment in
over
chat.
3 minutes until that moment happens. And so let's talk a little bit about
If you can
that,
find how to spell that
Nick.
word.
How exactly does Centaur
I don't
separate
recall ever hearing
from
that
Landsat
word
9?
before.
That's actually a cool little thing that happens is when it's time to separate, Centaur will send a signal to a device that's up there as part of the Marmon clamp that will release the separation bolts. And this Marmon clamp that is tied around, as you saw earlier in the upstand video, tied around on the bottom of Landsat 9, it will release that clamp, and Landsat 9 will then
We are
be
coming
pushed
up
away
on 2
using some
minutes to
springs.
separation.
Very little
This,
force.
I don't know about you guys, but this
Landsat
has
9
been
going
a
on
long
its
wait.
way for separation.
I did
So
not get
very simple design, but
I
took
did not
long
get a
time
full
to
night's
do.
sleep,
Our
and then I had to
mechanical
go to
engineers
work
have been
for
following this as they
7
mated
hours and then
Landsat
come
9
home and
to
do
the,
this.
to
I am
the-
tired,
the Marmon clamp,
and I
and,
apologize
they
if
made
I
sure
am not
everything was right
talking
from a
enough
tension
for you guys, but
perspective, and, you know, we're just
doing the
looking
best
forward
I
for that
can
set
for
moment.
you.
And we're watching now an animation that is tied to real-time data, so we'll see that moment. You know, it's interesting. You talk about springs putting it in the final moment. It takes rocket engines to get it up there, right? It takes rocket engines to get it close into orbit, but it does its final move with springs.
Yeah, absolutely. You know, we need all that thrust and power to leave Mother Earth and get out of her gravitational pull. But once we're in space and orbit, it takes very little work to make things happen. As we have watched Centaur and Landsat 9 orbit in this coast phase, we've seen the reaction control system just maintain Centaur in its space. So we're doing good, and that's just how rocket science works.
Yep, just about 70 seconds away now as we're counting down until Landsat 9 separation from Centaur. Once this happens, though, Mick, there's still more mission to go. There's some CubeSats on board.
Yeah, absolutely. Landsat 9 is our primary mission today, and once we separate Landsat 9, Centaur will begin its maneuvers in chilling down again the RL-10 engine and getting ready to restart.
NASA has
or what
got
we call
their
main engine start
logo
2 for a few
covering
second
the
burn
telemetry
there. And then they will do
a
a
little
MECO,
bit.
main engine cutoff again, and then we will do a third burn to get into the trajectory and orbit that we need to deploy the 2 CubeSats that are on board. And Daryl, you had mentioned earlier in the show, today is a first for us also on Atlas V with a 4 burn. We will do that 4th burn to dispose Centaur.
I appreciate hearing that, Noah.
Space jump.
We
point of
try
history
to cover,
for
we usually end up
Atlas
covering
system
about
and
1
Centaur.
launch a week.
We're listening now to see.
We're not sure if we're going to be able to cover
Let's listen
JAXA on
in.
Friday.
We're expecting spacecraft
Maybe it
separation
would be
at any moment.
Saturday or Thursday.
And we
I
have
need to check the
successful
time,
separation of the
depending on
Landsat
where
9
you are on the
observatory.
globe.
There you go.
So
It
excited
will be
for that.
a
I'm
different
so happy to
time,
hear
maybe
that. That
even
is,
a
just,
different day.
exciting to see
But
Landsat
we're
9
not
on
sure
its
if
way
we will
and
have
continue
anybody
that 50
available
years
to
of
bring
data.
that to you.
And there
If
she
we
goes.
do,
An
we will bring
impressive
that
sight.
to
It is
you.
an animation, but here at
Beyond
the
that,
Mission Director
let
Center,
me
there
look
was
at
some
upcoming
applause
launches
behind us from the
here.
people gathered here. It's a nice moment for them. It's a nice moment for you.
Yeah,
There
absolutely.
we go, that
saw,
one.
But it wasn't a huge celebration yet. I mean, we're very happy Landsat 9's on its way, but as we were just talking about, the
So there
mission's
would
not
be
over yet. We still have
JAXA
CubeSats to
on
deploy, and,
the
we want to follow
first.
this through for mission success for all of the payloads on board today. But that is a huge milestone to get Landsat 9 on our way.
And it's also interesting that Centaur has to be careful as it goes on to its orbit.
It was.
Put out those CubeSats.
It
It's
was
gotta be
due on the
careful to
5th.
avoid Landsat.
We have a Soyuz launch, MS-19, on the 5th. We have another one on the 14th. We have Lucy on the 16th. Electron from Rocket Lab on the 20th. And
CubeSat separation.
Well, that wraps it up.
Ariane 5 on the
We have launched here a
22nd.
successful on-time launch at 11:12 12 a.m. Pacific time, 2:12 p.m. Eastern time, from the central coast of California, an Atlas V
All right.
rocket.
And I think we are also going to wrap this up here. Thank you so much, everybody, for joining. There are some links in the description for if you would like to show us any support. We have a Patreon. We also have a paypal.me link. There's also like and subscribe buttons down there. You are welcome to push if you feel so inclined. Again, we have a lot of content that we provide here on Total Space Network. We have short videos, we have medium videos, we have long videos, we have news updates. We've got Deep Dive with Miko, Becoming Multiplanetary with Rich LB, and the Space Update with Ryan, and me, bringing you live streams as often as I possibly can. We'd like to thank our Mr. Producer Man, another space nut, who's behind the camera right now and can't talk to you, but we'd like to send him a thank you for doing all the behind the scenes work, as well as doing the total space chat in the commentary there. Go ahead and leave us a comment in the video if you're watching this after the fact, and we're gonna go ahead and let this finish up here, and we can probably play our end scene pretty soon here. So thank you very much, everybody, for coming. We really appreciate it. We'll keep you posted on future live streams and let you know when we're going to be bringing the next one to you. You guys all have a nice, great day.